Morning. Thank you. Thank you for joining on time. I really appreciate all your presence. One second, let me get into my console. So, how things are going on, Rise? Are you guys able to practice Ansible and all? Ansible and Terraform? Any questions till now?
It looks like one request. The commands, whatever you are showing in the meeting, right? We are not able to find them out in the training documents in GitHub, like Tomcat installation.
It's on the when you click on that training documents, just refresh it. I mean, again, click on that link on the same link. I mean, training documents. You will be able to get it from there.
I refer like DevOps introduction class, Ansible, Git, Jenkins, all the TXT files.
So for Terraform, you mean to say
No,
you don't get it?
no, for Ansible. Ansible, see, basically like when the training is happening, right? I see like Loksai is pulling some commands from other text pad and he's executing it, right? For example, the Tomcat installation, what we did last weekend. I was not able to find those commands or TXT files.
Guys, don't worry about it. It is already uploaded in the repository. I'll show you the link and the path where it is available.
Sure.
Yeah.
Okay.
Apart from the class notes, we have something for installation configuration, the practicing, right?
Yeah, correct.
So no worries. I'll be sharing that. It will be available. I'll show you that one.
Thank you. Yeah.
All right. So my concerns about your Ansible and Terraform module. How was that actually? How it went? Are you guys comfortable in those modules? Or do you have any questions?
Sai, I have a query for Terraform. I mean, let's we want to create an infrastructure for instances. Now, I have 5 or 6 instances, right? I want to create. So I can use the same secret key and access key for that. I mean, to create the 5 instances simultaneously in the single script.
Yeah, if secret keys and all, it is same. Okay, that is at the account level.
No, I mean, in the same region, let's say in Mumbai region, I want to create 5 instances, right? So I provided like the script on the top, like we saw last session. So it was, it would be same. Now, come to the part for instance creation. So what happened, like I have to define the same stuff, I mean, in the loop again and again for 5 times, or it should be okay?
Not necessarily. That's what I'm saying. Listen, please. So the source code, the provider, whatever given, right? That is at the account level.
Okay. Yeah.
So you don't need to give that for each and every instance you create, because that is at the initialization phase. Once it is initialized, your actual source definition is matters there.
Okay.
Got it? And if you want to create more than one instances with the same configuration, you can use one parameter called count parameter. Count equal to some value.
Oh, okay.
Normally,
So we don't.
Yeah,
Yeah.
normally when you launch the instance manually, we just go to the number of instance, right? If I
Right,
say
right.
1 or 2.
Yeah.
So what it means, based upon the existing configuration, is going to create that many number of VMs.
Okay.
Similarly, in the resource definition, we have a count key. Count followed by the value equal to some number. So based upon your number of request, it will create this VM and it all uses the same configuration.
So we
But
have
if you
to,
want to use different configuration, let's say you want to use different AMI or different security group, means you have to give the resource definition again, like create resource.
yeah.
Resource type is AWS instance, right? That we have
And
to give it again.
where we have to define that count value
In
inside.
the resource definition itself directly.
Okay. All right.
All right. So what we'll do now, let me share my screen. Is able to see my screen or not?
No, not yet.
Oh.
Recording in progress.
Hello. Hope now I'm audible to all, right? It's better now. Can see there is some deviation. Why there is less number of audience
Yes,
today? What's happening?
we are able to hear you.
Okay, okay.
But there is no screen share yet.
Yeah, that's what I'm picking up now. 1 minute. Let me take it from your ref.
Sure.
So here, okay. So this is what the class notes we had in the last session. And today we are on day 7. And it's 21st. See how fast, right, this year. Year is something very fast, right? The fastest. Okay. So, yeah, my concern is about the script, whatever I shared with you people on that day. Like, did you get a chance to go through the script and try to cover all these things, starting from VPC creation, everything? Right? Did you get a chance to execute this, or you just tried with a simple level?
As for me, I just tried to create the instance and check the type of, I mean, number of instance. I haven't go through this like in detail.
This document also I uploaded in your repository. I hope you have that reference.
Yeah. You could find that document. But what I was just referring is, no, Sai, the Tomcat installation during the Ansible setup, right?
Okay. I'll check that once.
Yeah.
1 minute. Okay. So you have for Jenkins master and slave nodes, and you're expecting for a Tomcat server configuration, right?
That is correct.
All right. Apart from that,
That is the only thing what I found so far.
Okay, no
Yeah.
problem. I'll do one thing. I think it is pointing to some other file. Let me take that for you now. And we have installed Tomcat in our Ubuntu machine, right?
Correct.
Correct. It's an Ubuntu only you did, right? Or in Fedora?
Ubuntu only.
Okay, then I'll just share the same.
Yep.
It is. Okay, it is in a different folder, I believe. Let me remove it from there. So I'll do one thing. I'll just keep the same in your Jenkins repository. This is a repository, right? You are using RDevOps2. So here we have a configuration Jenkins master, slave. So here it is no slave node configurations there.
Yes.
And I'll do one thing, just keep it here itself.
Yeah.
So now you can able to see something for your Tomcat server installation.
Correct. So basically, looks like the point what I'm highlighting, right? When we are doing this configuration, class path setting, and etc., right? You are referring the nodes what you have already used it, right?
Yeah.
If you can kind of like either upload them or add these things as part of this one, it will be helpful for us to kind of like practice it by the time we come to next week.
Yeah, that's what I'm doing actually. But I think this Tomcat is pointed to some other folder. That's what it is.
Okay.
Okay.
Yeah.
On daily basis, even your Tomcat, your last session, Ansible, Terraform, everything is there, right?
Yes, correct.
So that's what it is. The same folder, but this is something pointing to different folder. That's why you don't find it here.
Yeah.
So I just kept it now. You can make use of it.
Perfect. And the class path also, right? I think the entire setup. Class
yes.
path. Okay, perfect.
Yeah, it's there. Like, yes, it includes everything.
Yeah, sure. Thank you, sir.
Okay. So let me commit this. Thanks for bringing that.
Yeah, no problem.
And your class notes are up to date. And then Ansible, what we have for Ansible. And Terraform, I just kept a separate folder last week itself.
Correct.
And in Terraform, I just kept a practice document. Apart from class notes, I given for practice also, like how you can able to launch a simple instance without any other additional configuration. And apart from that, we have something for entire thing, like starting from the providers, VPC, subnet, everything. So the workflow is very simple. You have to create one folder in your, what do you call that? I mean, you're using Visual Studio Code or any other editor? I believe it's Visual Studio Code, right?
Yes.
Just create a folder of project Visual Studio Code and create a new file for your AWS Terraform file. And then use these scripts there. Once the script is ready with the valid access key and secret key, just give init command and then proceed with the Terraform plan and apply. So you should be able to see all the resources. There are nearly 7 resources we're going to create here on a single go. Everything should be created in your target environment. All right. And I showed you a demo for destroy command, right, that day?
Yes.
So using destroy command, you can able to delete all the resources. What are things you have in your thing? And one thing I want to highlight here is about the best practices. Okay. So let's say script are not an issue. Script everyone we can able to do because it's all we are going to pick it up from the official documentation, right? From the Terraform registry only, we're going to pick up the scripts, and it's always recommended to pick up the script from that level only. But the point is the Terraform state file management. This is one of the important responsibility. People who are working in Terraform, we have to be very cautious in handling the Terraform state file, because the state file is going to have the current state and the target state, right? What are things you configured in your file? What is your current configuration? And if you want to create the resource, means this resource should not be available in target environment, right? So that state is going to decide by state file. And if you create your configuration in local machine, assume that I have nearly 5 members in my infra team. All 5 members have their own local machine, and in that local machine, they are trying to define the resources. So if they do it like that, what will happen? On their local machine, they'll be having independent copies of a state file, right? Correct. So if all people are trying to work on the same resource definition, it is not recommended to work on an independent folder. All that we do is we just maintain these scripts. We just maintain the scripts in the remote repository. Like the project, whatever you have created, right? Which includes your aws.tf file and the state files backup, everything will be maintained in the remote repository. No need to maintain the provider. Providers are something used for, execution purpose. That's all. That can be in local machine. That's a one-time activity in it. But the resource definition and the state file, that is your TF file and state file, should be in the remote repository. And any person who wants to work on this project, they'll be directly cloning the repository from the remote environment using Visual Studio Code. Hope you know, right, how to clone the repository from Visual Studio Code. So you can directly clone the repository from Visual Studio Code, and they can able to make the changes online, so that everyone can able to have a same copy or same version of their state file, which can be uploaded. That is how we just maintain the state files. That's very important question. So as a best practice, we'll be doing it. And one more thing, as soon as the changes are done, it is the responsibility of the person who is working on that requirement to upload the latest state file to the repository, so that everyone will be in sync.
And Sai, there is a question regarding this init command. When we init it, I mean Terraform script, there would be a file created, said like terraform.lock.html. So what does it mean? I mean, what it represents?
But the final apply command will fix that issue. I mean, fix that file.
Yeah, it fixed it, but on the left navigation bar, if you can see under the folder, terraform.lock.html, and when you click on it, I saw something like, it was locked by initially when you fire the initial, I mean, init command, and then registry, it says like HashiCorp code, like encrypted code.
See, that is what the scenario we're discussing now, right? I have a project which is having this definition, right? In the Visual Studio Code project, I have the aws.tf file, and I have a state file. All the resource definition, everything is there. So
Okay.
if the state file is being shared with more than one user, let's say I just done with my work and the changes are published to my repository. The changes, whatever I made, it is available in source code repository. Now, anyone from your team might work on the same resource definition. So while he is working on the particular changes, meantime, no one should able to access it. So it should log that state, current state of that thing. Because while you are updating, if someone else update the same content, then it will create a conflict. Correct? So whenever the repository state file is created, during the process, starting from your plan till you complete the apply activity, the state will be locked for your transaction. Got it? And whenever you try to create a new version of that state file, whenever you make any change source code script, a backup file also will be created. Hope you must have noticed a TF state backup file, right? Hello?
Yeah, that's right.
That is what the
So,
purpose.
so initially, let's say if we want to create a new infrastructure, right, with another region, sorry, in the same region, but with different instance. So at that time, we can use this backup copy of the state file, right, to create the same one.
No, backup copy is just for your backup purpose. Let's say today you have created an instance using Terraform, and you made some incremental changes on the resource. You might have updated the security group, or you might have updated the tag, key, or whatever changes you made. If you want to revert the action, what you'll do? You know the previous configuration, right?
Yes.
So that previous configuration is available in your backup file. So you can simply refer that. Normally, we just rename the file to a latest one, or you can copy paste the content from the backup file to active state file, and it'll get executed. That is how we just that is the reason why we have a backup file. Are you getting your point?
Yes.
And if you are using it in your local machine, you'll be having only one backup file. Like the current version is, the present configurations will be in a state file, and the previous configuration will be in the backup file. You can't get the previous to previous versions and all. That is the reason we recommend, as a best practice, we make the people will recommend the people to have it in a repository, source code repository. So in source code repository, whenever you upload any file, it will be version controlled, right?
Okay.
Easy.
Sai, can you come again, like, which files comes under for what purpose? Like state file is to like a summary.
Sorry, we are not able to hear you in case if you are talking. Is anyone able to hear Sai? Hello.
So what was the question? Like, can you please come again, guys?
For what purpose, which files we are using? Like definition file, we already know. Log
Okay, see
file is
here,
to
in my Terraform project folder, I'll be manually creating a configuration file, like for example, aws.tf. This is what the file which I have created, correct? Hope you remember, right? Hello, I'm audible?
Yeah,
Hello?
yes, it's audible.
Okay. So once you create this file, what we do, we just give Terraform init. So init means it is a process of initializing your providers. So it will just download the exec file and have it in your folder, correct? Hope you must have noticed it. And then you'll be issuing your Terraform plant command, and then Terraform apply command. So during this process, it creates some files. Like we have something called log files. It is just a dynamic one, okay? It is not a static entry, it is a dynamic entry. Till you complete the apply command, this log will be existing, otherwise it will get released. And apart from that, you can see something called tf state file, and then tf state dot backup file. So what is the purpose of TF state file? Means this maintains the current status of the target environment. So it means assume that in my AWS TF file, I will create a configuration. Let the configuration be something like this. Got it? I just created these two resources. I mean, this AWS instance. And once I issue apply command, this changes will be updated in the target environment. It means the instance will be created there. Once the apply is successful, that is what the current state is. Through Terraform, you just achieve something. That current status will be uploaded in your state file. Got it? By the time, if there is a very first time activity, by the time you won't find any backup file. Now, over the period of time, you are making some incremental changes. Let's say you just modify this server name or a tag, and you just apply plan and apply command again. In the case, you are just making some incremental changes. So whenever make any incremental changes, now this should be considered as a current version, right? So this current version will be updated in the state file, and the previous version will be updated available in the backup file. Easy? Hope you're getting a point, guys. So this is what the importance of files which we have. And at any point of time, let's say I want to revert my changes. I want to go back to my previous change, means all that we do is we can simply rename it. Let's say I just make this as a TF state file, and this is a dummy file I can consider. If I make it as a dummy, and if I make this a TF state, now I'm just trying to consider this as a current state. Terraform will consider the country entity, whatever you have, this as a current state. It will try to update the scenarios accordingly. So it's all matters, okay? How you are trying to manage resources, it matters. And this is very much important when you try to automate that scheduling. Let's say, I think last week we discussed about some pipeline workflow. Did we?
No, we did not.
This one. I just gave one example, right? How we can able to create a server and configure it. Can you see this?
Yes.
So if you look into this workflow here, I have SCM checkout, application build, and I want to create a QA server. So once a QA server is created, it get configured, and then only the deployment will happen in the QA server. And once the deployment is done, we can able to perform some automated testing. And once automating testing is successfully completed, then we can promote the code to the next environment. But if this fails, what will happen? Again, the developer will be notified. He'll be uploading the new changes, and the new changes will be built. And now it will try to deploy the application QA server. But the QA server is already available. Based upon previous build, we created a server. So I don't want to create it again. So this will simply bypassed. Like this, we can able to implement some. It involves some scripting level also. Like we need to write some Groovy scripts or shell scripts to automate these activities. It's possible. Easy. So the main objective of state file is to avoid or prevent the duplicate resource definition. Any question?
Sai, this content of .exe file, we can't see it in this editor. What we can say, Visual Studio Code. It's in binary, right? So
See, it's a exe file, right? Binary. Remember last week. If you consider this link here, See, the init command, it is going to ultimately download this version, this file. It is not a source code, it's executable. exe files are just executable. We can't see the content or source code of that, right? That matters. So this is what the init command is going. It actually just downloads this version in local, and using this version only, you're going to do all sort of resource definitions.
Okay.
Easy. Okay, so just follow this and try to implement this also, but there is no difference whether you're creating one resource or multiple resources, that doesn't matter. But understanding workflow is very important. And you can able to refer these commands also. I already posted these commands in your notepad, right? So you have Terraform init command, plan, apply, destroy. And if you want to know the list of resources that is defined in state file, you can able to give a list command. And whenever you give apply command, right, it asks for the approval, no? Whether you want to proceed or not. You give a command yes, right? Have you tried it? When you give Terraform apply or destroy, it will ask for the confirmation whether you want to proceed further or not. You have to manually type yes command there, right?
Yeah.
Yes.
So that is okay if you're doing it manually through your Visual Studio Code. If you want to do it, you can do it. But when you try to automate this process, you can't manually interrupt there, right? So what you can do means, as part of apply command, you can use one option called auto approve. -auto -approve. This option will automatically proceed with the next level. It won't ask for any manual intervention. Correct. So please try this, and this is how, even based upon same principle, you can able to work in any target environment. It can be your Azure or whatever. All right. So shall we move next module?
Sai, one question on the pipeline. So for this SCM checkout application build, when you are creating the Terraform script for the first time, you kind of like implement these and create the script to execute this one, right? So with that, you're able to build the application and deploy into QA server, create the server, and test the application. Fine.
Yeah, that's right.
Well, let's say after that, like there was some changes has happened. So you mentioned that the existing script, Terraform script, has create QA server, config QA server. But in the second time for enhancements building, we don't need those two steps, right?
Yeah, that's right.
So how are we going to, do we need to kind of like update that existing Terraform script to ignore those two steps?
No, here in this case, we can able to define some dependency. Only if this step executes, you can able to run this step. There is one option called based upon. Based upon this step, only this step will get executed. But if this step itself not executed, then no need to go with this one.
Okay, so we need to introduce some dependencies for the multiple runs, what we are going to do. Okay, got it.
Yeah. This is one of the examples. I wanted to give one more example that is considered as the best practice when it comes to the automation. So what we do means we'll be defining some upstream and downstream jobs. So this upstream job, what is going to do means it is going to create the required server and configure the server. And the downstream job, it is just going to follow the traditional SDLC process, whatever we do. Because at enterprise level, we'll be defining this job template, right? This job template is common, correct? Any application onboarding will perform all these activities. So in between, if I want to introduce this means it is an ad hoc requirement. So without disturbing existing CSD pipeline, how I can able to automate my server provisioning means I'll be having a separate work stream here. So now this job will get executed first. Once this job is successfully executed, I can consider this job as a downstream job. Based upon the successful status of this job, I can able to trigger this.
Yeah, this makes sense more. Yeah.
Got it. So in this case, I can have this as a completely isolated process, and I can able to apply this at any scenario.
Right. And in future, in case if you want to modify the configuration for respect to SQL Server, then you can simply update that upstream job one.
Yeah, upstream
and
job
then
one.
execute.
Yeah, that's right.
Got it.
Easy. Are we
So
good?
if we update the infrastructure, let's say we make some changes in the script. Now we initialize, right? So at a time, we have to do it, I mean, every time upon the changes in the code.
Mm-hmm.
And then we can plan it and apply it, right?
Yeah, that's right.
Okay.
Okay. So the next thing in the list is about your Docker. We have 4 more modules, right? Like Docker, Kubernetes, and then what do you call that? Monitoring, which includes your Prometheus and Grafana. All right. So now we'll move into Docker module, shall we? Shall we?
Yeah.
Yeah. So ultimately it's just a Docker, okay, but we usually consider a technique called containerization. So containerization, it is one of the important terminology when it comes to deployments. So before you actually talk about containerization, first we should understand the typical build and deployment process. Whatever we did in Jenkins, okay, and what are the drawbacks we have there. Then only you can able to understand the importance of containerization. So let's have a quick recap of what we did there. In our previous module, we have Jenkins master and Jenkins slave, right? So what is the purpose of Jenkins master here? Why we have Jenkins master?
For defining the workflow. Mostly setting the pipelines.
So this is to create or manage the Jenkins pipeline projects and schedule it. Correct. This is what ultimately we're going to do. We never run any jobs in Jenkins master. The build will happen in the slave node. And what is the purpose of this slave node one? Let it be one. I can consider this for my Java application build. Possible, no? Similarly, if I want to build my Python-based application, can I able to do it here? Is it recommended as per the process? Technically, it is possible, okay? Technically, your slave node, even the master node is capable to run the build. But as per the process, in order to balance the workload, we just go with the slave machine. Like we can have one more slave machine. That's what we have discussed, right? Earlier module. Correct. So like this, we have various tool stack available in market. Various types of applications. We have many different application teams. They use different tool stack. So point here is, if there are nearly hundreds of tool stack available in market, and if my enterprise No, application development team. They are working on all the other types of tools, all the other types of application builds. So is it feasible to launch that many slave machines for each and every tool stack? So earlier when Jenkins was in place, that was the main issue because each and every slave node is a VM, right? For the sake of demo, we are using T2 micro instance, which is free of cost. But in real-time environment, we never use T2 micro. At least it'll be like a T2 medium or large with 2 CPUs and 4 GB RAM. Is billable. Even if you run for a minute, it is a billable. So how we can able to avoid this thing? How we can prevent this? That is the reason we go for a containerization. So containerization means it is on a high level, okay, it is used to reduce the number of VMs. Ultimately, using containers, we can able to reduce the number of VMs. So basically, what is a VM? Virtual machine. What do you call this?
Server.
Sorry?
Server. For server, we are using it.
How we create a VM?
By launch.
Come again? By?
Launching.
No, I'm not talking about that actually. I'm talking on the underlying architecture. Maybe
In
from
cloud.
your console, you are simply using your launch option or using Terraform, you're creating a VM. But actually, what is the basic requirement for VM?
Hardware server.
Some
Okay, first of all, tell me why we need VM.
Subscription.
Okay, first of all, tell me why we need VM. This question looks very silly, but it's all very much important to understand the core of your containers and Dockers. So just let me know why we need VM.
To operate it from anywhere.
To operate from anywhere?
You don't need to have a physical, what you call, equipment with you, right? Once the VM is created, you can simply log into that server from
In any system.
any system, yeah.
It means you are talking only on the cloud platform. You can't create VM in your on-premise environment?
Yeah,
we can have, application reside on those VMs and access it. So, for that point,
there will be a lot of dependencies, right? So if we create a VM, we can have whatever the configurations we can, and we can install that. And
our client is having products and for testing purpose, we create their local replica in the form of VMs for testing if they find any issues. So for that purpose as well.
And also it's kind of easy to maintain, right?
I think what are the points you are giving? It's all closely related to the benefits of cloud computing. Okay, but the point here is about the VM. VM is a core. Let's say, forget about cloud. I don't have any cloud platform. I'm working on my on-premise environment. No need to go with the business level also. As an individual, I'm a trainer. Next week, I have a batch for my Linux administration. Next week, I'm going to start one batch for Linux administration. So in order to demonstrate the Linux administration and its components and its modules, I need a Linux machine, right? Correct? But I have a laptop which is installed with Windows machine. This is my laptop, which is installed with the Windows operating system. This is my hardware. It can be my CPU or RAM configuration, whatever I have. And on top of it, I have just a Windows operating system. Windows 11 is running here. So now I have a demand to create to showcase the Linux machine. So is it possible to run Linux on Windows?
Yeah, we can run. There is so many options called VirtualBox, and
Is it possible to run Linux on top of Windows?
no, that's why we are using VMs, right?
By default, you can't run.
Yeah.
Okay. If you want to run any other operating system on top of the existing OS means, we'll be using the
Virtualization.
concept called virtual machines.
Yes.
And I'm not talking about the virtual machines on my cloud platform. I'm talking about my local machine. This is my local machine. So in this local machine itself, I want to create a VM. Is it possible? That is done through the hypervisor. So on top of this Windows OS, I'll be installing a hypervisor. And using this hypervisor, I can able to create a number of VMs. Like this is my VM. 1, 2, 3, and 4. Got it. And each VM can run in its own operating system. Like this can run Linux Ubuntu machine, or this can run CentOS. This can be a Fedora, right? Or this can be a Mac. Whatever it is, we can able to do that. Even in VM, I can run some Windows also. I can have. Got it. So ultimately, what we did here, we have just installed the hypervisor. Hypervisor acts as a middleware product which runs in between your base OS and the VM. So using this hypervisor, we can able to create any number of virtual machines. And what are the virtual machines you are running, right? It's all used to run the operating system basically. It can run in its own operating system. And each and every VM, it consumes the resource of the underlying machine. Like the hardware, whatever you have in the underlying server configuration or a system configuration, it uses it. So it means, let's say, for example, consider in my laptop, I have around 16 GB of RAM. And I have 2 core to CPU. So how many OS we are going to run here in this machine now? As per this diagram, how many OS are running?
Maximum we can utilize 16 GB. So
It's 5 OSs running.
At
5.
this point, we have 5 OS,
Yeah.
right? So
Yeah.
these 5 operating systems are going to share this hardware configuration is being shared with all these 5 operating systems. Got it?
Yeah, the performance will be slowed down, right?
Yeah, that is what the point here. So
Okay.
whenever I try to configure my hypervisor and launch a number of VMs in my on-premise environment or in my local machine, definitely it degrades the performance of my underlying hardware. Correct? Yes or no? I can't quickly scale up or scale down. That is the reason we are going for a cloud platform. So in cloud platform also, we are going to do the same activity, but it will be configured on a high-end server. Here in my local machine, I just have 16 GB RAM, but in real time, the cloud platform, they have a very high-end configuration, which can accommodate a number of VMs, and it will be scalable. So let's say you're creating a virtual machine in an AWS platform using launch option you're doing means, do you think a dedicated server is allocated for your VM? So in that AWS platform, we have something called region, AWS regions, like Mumbai region or whatever, right? And within that region, they have something called availability zone. Hope you remember. That availability zones are nothing but the
Yes.
data centers.
Yes.
And in the data center, they'll be having the servers, right? So assume that this is one of the server. This server also will be having the hardware configuration. And on top of that, they'll be having the operating system. Ideally, it will be Linux based. And on top of that OS, they'll be having the hypervisor. And whenever you create a request to create any VM, it will choose based upon region and availability zone. It will identify one server which is available at the moment, and it will try to allocate one VM for you, whatever request you are specifying here. And when you try to launch another VM, it is not mandated that the another VM also will be allocated in the same machine. It can be allocated in a different server based upon the availability. Is that clear? So it means what are the virtual machines we are creating in a cloud platform? It is not getting allocated in the same server. It depends upon the availability. It can get allocated in any available server. Got it? That is why it is called as virtual. On end user perspective, we can't figure out in which server it is running actually. Upon execution, I mean, once it is up and running, then we'll get to know in which server it is running. Got it? That's why it is called as a virtual machine. It is running a cloud platform. We are not allocated with the dedicated server. Server is different, VM is different. This server is capable to run multiple VMs. If I install a hypervisor here, then I can consider my laptop as a server to run multiple VMs. So whenever you launch any machine in cloud platform, you're not launching the server, you're just launching a VM. Hope you can understand the difference, right? All of you?
Yes, very clear. Yep.
Yes.
So now the point here is, whenever we talk about the VM, VMs are basically used to run the operating system. Like even when you launch a VM also, you're trying to choose the AMI, right? What is AMI? AMI is just a Amazon machine image, which is going to refer to a specific operating system like Ubuntu or Amazon Linux or what do you call that, Mac or Windows, right? So basically VMs are used to run the OS, and on top of the OS only you can run some applications. Like it can be Tomcat application or Nginx or Jenkins or Maven. What are the applications you want to run? You are running all those applications on top of the operating system. Clear? So ultimately the VMs are meant for running the OS. Please keep this point in mind. It is not to run any application directly. Can you able to run any application without OS in the VM? No. Means first VMs are meant for running the operating system, and on top of it only you can able to run some application. And even if you don't have any application, also VM will be up and running, correct? Let's say you just launch one machine and you never install any tool on that machine, but still it is up and running, correct?
Yes.
So that is what the basic property of VM. VM is not basically meant for application. It is meant to run a OS. Even if there is no applications available, it will keep on running. What is the use of running the VM without any application? Correct. Ultimately, I'm not here to run any OS. OS is just like an interface between my application and the hardware. But my application is a very important thing. If I don't have any application, then why I should have a VM up and running? So these are some drawbacks when it comes to VM. So to overcome this only, we go with a concept called containerization. Got it? Containerization.
Sorry. Can you please explain one more time on the drawback? What is that?
Okay. It is not, don't consider as a drawback. It can be considered as a properties of VM.
Yeah.
Okay. Hope this workflow is clear, right? Drawing diagram
Yes.
is clear, right? Can I clear the screen?
Yep.
All? Okay. So let me clean up the screen. So ultimately VM, whatever VM we are talking about, I said very first point what I said, it is going to utilize the underlying hardware. The configuration of hardware will be shared with more than one VM. So VMs are, it is virtualization, or VMs are considered as hardware level virtualization. Got it? No VM is using the property of the underlying OS. Let's say if you create a VM and you install Linux, means that VM is not using the property of the underlying Windows OS. It is utilizing the property of underlying hardware. Like if you have 16 GB RAM, means the 16 GB RAM will be utilized by the VM. That's all. That's why it is called as VMs are considered as a hardware level virtualization. And it is basically used to run the operating system. But it is used to run some operating system. Clear? That is the second point you should consider. It is even without any application. So even if there is no applications available, your VM can be up and running. That's what the point here. Any question here? Any question? Guys?
No, good so far. Yes.
Okay. So now assume that I have a VM created, and in that VM, I just want to deploy an application. So what is the purpose? Like in our previous module, we have used a QA server, right? The QA server, what is the purpose of QA server? We just launched a QA server to run an application using Tomcat application server. So it means my Tomcat application server should be up and running whenever I try to test my application. Once my testing is completed, do I really need that? The Tomcat server can go to stop state, correct?
Yep.
And once I stop the Tomcat server, why I need that VM to be up and running? It won't go to stop state by default. It continuously running it. So it means it consumes a lot of resource there. So to overcome that, what we do means we'll be going with the containerization. So the containerizations are considered as a OS level virtualization. It is not at the hardware level, it is at the OS level. So if you want, I can show you one small workflow for that. You can consider the same machine. Sorry, I'm not that much good in scribbling on screen with this pointer. Hardware. And this is my operating system. This is my base OS on this machine. And if I want to install VM, what I need, if I want to configure VM, what I need here? Hypervisor. But instead of hypervisor, you can able to have a container engine if you want to create a container. That's a basic difference between your VM and container configuration. So this VM machine, it can have a hardware and it can have something called base OS. And then this can have a hypervisor. And on top of it, you can have a number of VMs like VM 1, 2, and 3. This is meant for running the operating system, basically. It can be Linux OS, Windows, or Mac OS. Now, if you want to containerize it, instead of hypervisor, you'll be having the container engine. And this container engine is capable to create a number of containers like container 1, 2, and 3. So what is the basic difference between VM and a container means? VMs are basically used to run the operating system, but the containers are used to run the application. It is not meant for running the OS, it is meant for running the application. That's the very first thing to consider. And to run the application, it needs some operating system, right? The base property of OS, right? Yes or no? Without OS, we can't run any application, right? In any computing device. So that level of isolation, how many containers you are running, each and every container will be using the property of the underlying operating system, not the hardware. That is the reason it is called as a OS level virtualization. Each and every container utilizes the property of the underlying operating system, and based upon the property, it will run the application. But the VM means it utilizes the underlying hardware, and based upon the hardware configuration, it runs the OS. Because to run a OS, we need a hardware configuration. So that makes a difference. So now the point is, since containers are capable to run the application, It is basically used to run the applications, not operating system. Okay. Containers are basically used to run the application, not operating system. It's a very important point. And because of this, the containers containers consume less resource. Obviously, right? Resource means it can be a CPU or memory. There is a huge difference between running the application and running the operating system. To run the operating system, you need huge volume of storage. But to run an application, it doesn't require that much volume of storage. So it consumes less resources when it comes to CPU and memory. And because of that less resource consumption, containers are faster in boot up as well as in execution. Got it? Are you getting your point now, guys?
Yes.
I'm just talking about the
Yes.
properties of the virtual machines and the containers now. So containers consume less space and resource in terms of CPU and memory because it is trying to utilize the underlying property of the OS. And because of it, it is very faster and boot up. If you want to start the container quickly, within few seconds it starts. Not in few seconds, few microseconds starts the container. And the application, whatever you execute in the container also, it will be very faster in execution. Clear? And one important property of container is, since the containers are basically used to run the application, not operating system, right? So if the containers will automatically go to exit state if the task or application completes. That is another important thing. So it means, let's say I create this container. This container 1 I created. It is running some application. Assume that I'm running on Tomcat application. We are doing some sort of transactions there. Once the application is completed, automatically the container will be deleted, or not deleted. You just go to exit state, or you just go to stop state. And once it is stopped, it will release all the resources. What are the resources it has consumed for the execution? It releases all the resources and free up the resource for other containers. Are you getting a point? Are you getting my point now? So once the container task or application is complete in the container, it just go to exit state, which will free up the resources. But the VMs are not like that. Consider in a particular VM, I'm running on application. Even if I end the task, even if the application is exited, VM will be continuously running, right? Till I manually go and stop the instance. Hope you're getting a point, no?
Yes.
Let's say I have installed Jenkins in one VM. The Jenkins is up and running. I don't want Jenkins anymore. I just stop the Jenkins servers. Even if I stop the Jenkins server, my VM is up and running, right? At the backend. So that's what the resource utilization of VM. Because it is not meant for any application, is running for the operating system. That makes a difference. And another important point here is the containers runs in a completely isolated. Okay. That means whenever you run any container, each and every container will run in its own address space, isolated address space. Got it? Let's say you are running on container. This container, which OS it is using and which application is running, it will not have any clue about it. That means the underlying OS will not have any clue about it. It is completely isolated. So as I said, it is going to use the property of the OS, right? So in order to achieve this isolation, it uses two properties of the base OS. That is, we call it as a control group. In short, we call it as a CG. And then namespace. So these are the two important properties of the base OS, the kernel. It's all core OS property. So based upon these two properties, it will create an isolated environment for a container to run and execute. Once the process completes, that space will be freed. Any question?
Namespace is for what? I mean,
No, you are getting the property of the containers and VMs right now.
yeah, we got.
Okay. So namespace is what? That's what your question?
Yeah.
Okay. See, in a Linux machine or in any Windows or any operating system, any computing device, whenever you start a task, the task will be having its own process ID, process name, process group, right?
Yeah.
Even in your Windows machine also, if you go to task manager, what you can see there? It will get you the list of tasks that is up and running with the valid task name, when it is started, and in which address space it is running, and what is that IPC, inter-process communication, what is the network, what is the volume, everything will be associated to any task. So that is what the basic computing environment. In any computing environment, whenever you run any task, each and every task has its own properties. Got it? If you are running the task in your machine, the task whatever you run, it uses the property of the base machine. That's all. But if you run any task in the container, it is associated within the container. The task whatever you're running in this container, it will not expose it to any other container or any other base OS. So it means it creates a completely isolated namespace. Within the namespace, it runs the container. That's what the level of isolation. I'll talk about all these things are very much important when it comes to microservice architecture deployments. Actually, I'll talk about in the future, but as of now, understand your containers will run in a completely isolated platform by using the underlying property of the kernel, that is control groups and namespaces. So each and every container which runs a task will be allocated with a unique namespace with the valid process ID, inter-process communication, networks, volume mounts, and all the core OS related properties. Okay. So let me clean up this. So now, how you can able to compare this with your VM now? You can add few pointers here, right? So since it consumes less space, so and really considerable amount time to boot up. Hope you must have experienced, right? From your AWS console, if you try to start the VM, it is taking some time to start, right? Correct? It's a basic property.
Yes.
Even if you start your laptop also, it takes some time because it is the OS. First, it has to what is it called? Collect the OS related properties, and on top of it, it can run the application. So everything matters there. So this is what the basic property of your VM and containers. So now, what do you feel like? Which is advantages and which is having some drawbacks? So obviously from this pointers, we can say containers are very advantageous, right? When it comes to application execution and deployments. But the point is, containers are not to replace the VMs. We can't eliminate the VM. VM should be there. So ultimately, we using containers, we can reduce the number of VMs. That's what we can do. We can't completely eliminate the VM. That's not the use case. Are you getting my point? Okay. So to explain this, I'll just give you one example. Okay. We can able to consider containers or containerization. I mean, in order to understand the importance of containers, you can able to take it on two perspective. One is on operations perspective or infra perspective. And another thing is on your application development, or it can be on your deployment perspective. It means to understand the importance of containers, we are going to talk about these two perspectives. First thing is about infrastructure. So how containers are going to add value to your infrastructure provisioning, how it is going to save the cost there. As I said, we are going to use containers to reduce the number of VMs, not to completely eliminate it. So let's say, for example, in my previous module, I was talking about something related to Jenkins master slave architecture, right? Once upon a time, did we? Ayo, எங்கேயோ போகிறது. Can you understand this architecture somewhere? I mean, remember, right? What is the purpose of this? Hello?
Yeah.
Okay. So now you know what is the purpose of Jenkins master and what is the purpose of each and every slave nodes. And in real-time environment, each and every slave node consumes a lot of billing, right? Cost matters there. So on infrastructure perspective, how we can reduce the cost? Let's say this is for my Java application because I need to install some Java build tools. And this is my Python-based tools will be installed here. And this can be for my web, what do you call that? Angular or some Node JS kind of applications, or it can be a .NET application, whatever it is. So for each and every tool stack, initially I was dedicating a VM and I can able to route the request to that VM for deployment. But now if you introduce the containers here in this level, all you can do is we can able to achieve all these things. This is using VMs and this is using containers. So using containers, how I can able to change the architecture of Jenkins means I'll be having Jenkins master. I don't have any problem. But my requirement is I want to do some sort of build, but I have nearly 100 different types of applications. Got it? So what I'll do here, I'll be having one slave node. And in the slave node, obviously it's a VM. I'll be installing container engine. So once we install container engine, what we can do? What I said about that in the architecture.
You can create multiple containers.
Yes. So if you want, I can add the point here. And here I can add the last point. Maybe it will be useful for your future reference, no? Okay. So now in this slave machine, this VM, I'll be installing the container engine and I can able to create one container. So assume that this container 1, this is meant for my Java application build. I'll be installing all the required tools in the container and I can able to run, perform build and create artifacts. Similarly, if a team is requesting for another different application means I can have another container. And this is meant for my Python based tools and build. Similarly, as per my need, I can able to create a number of containers. And this can be for my, what do you call that, Angular. And this is for my Node. So now if you consider, if you look into this architecture, we have completely reduced the number of VMs, right? Instead of 4, I have only 1 VM to perform all these things. And one more advantage here is, once the build is completed, this container will automatically go to exit state by releasing resources. So VM will be having enough room to accommodate new changes or new builds. So you don't need to go with any maintenance or manually do some sort of cleanup activity. It automatically free up the resources. So like this, on infrastructure perspective, as a DevOps engineer, we can give our recommendation. Like by introducing containers, we can able to reduce the cost of VM in real-time environment. You can able to run everything. Even if you are talking about the mature level of implementation, you can run Jenkins master itself in a container. It's also possible. I don't want a dedicated VM for master, or I don't want to have a dedicated VM for slave. So the current setup, what I have configured is virtual machine. There will be one VM, and in that VM, I have a container that will run my Jenkins master. And another container that will run my slave nodes. Like this, for each and every slave, I mean, each and every build, I can have a number of containers. So with a single VM also, we can able to control all those things. But it requires some sort of matured level of implementation. So point here is, we are not going to completely eliminate VM, but we can able to reduce the number of VMs on infrastructure perspective by saving the VM cost. Are we good with this?
So let's say once the containers, I mean, as you told that once the application or a task would be completed, the container would be in exit state. So what if we want to back it on? I mean, can we make it up or?
You can start it again, no problem.
Okay.
You can start it again, no problem. But while you start that container, you should have some task to run. If there is no task to execute, then there is no, it won't start it. It will immediately go to exit state.
Okay.
Okay, that is about your, what do you call that? Containers and VMs at the infra level. Guys, am I making things clear to all or any confusions here?
Yeah, theory part is okay. We just want to concentrate on that
This is not
implementation
theory,
part.
it's a concept actually.
Yeah, like it was like
Okay, if you say
explanation.
theory, it's a boring content. Okay, I'm not talking
No,
any theory here. It's a
I
concept.
mean like yeah, it's explanation.
Fine. So this is about the infrastructure perspective. Similarly, I said there is something on development or deployment perspective, right? So how containers are going to add value to your deployment, especially when it comes to microservice architecture. This is what the main agenda here. So what is a deployment basically? How you perform deployment? Questions look very silly, okay? Maybe it's very silly for your level, but it has some value. So whenever we talk about developers, right? Developers, what their role? They just create the source code. And once the source code is ready, what they do?
They will deploy in a QA
We'll
server.
create the build and then give it for testing.
Artifacts will be deployed in a QA server.
So as soon as they create the artifacts, they'll be promoting to testing environment.
Yes.
Are you sure? Are you sure about it?
That is what we did earlier.
Come again?
That is what we did earlier.
So it means any developer can able to create the source code, create artifacts, and without even testing it, they'll move to the next environment.
No, we have run in a Tomcat, right? So that's
You will be doing the unit testing, right?
They are doing the unit testing. Yep.
Even in your CSD pipeline also, we have introduced unit testing there, right? Hope you remember. So without proper testing, no developer will promote their code to the higher environment. So unit testing should be done in their environment. So to do the unit testing, they might need artifacts, and they'll be doing all sort of testing there. And depends on the application, whether they will do the automated unit testing or manual testing. It depends. So now assume that a developer is doing unit testing, and to do the testing thoroughly, he need to run the application, right? Assume that this is a WAR file, my web app.war file. So this artifact is created, and this is getting executed by the developer on his local machine. In his local machine also, he'll be having a Tomcat installed, and it is integrated with their Eclipse IDE. Eclipse, you know, right? Eclipse IDE, where they can able to integrate the Tomcat on their local dev environment. And with that tool, they can run the application and do the testing. Tomcat server. Now, once it is successful, he'll be promoting the code to the next environment, target environment. So in the target environment, if you want to run the application, what is the need actually? What is the ultimate requirement here?
Pipeline to deploy the build in target environment.
I'm talking about testing to run the application.
We do have prerequisite for Java must be installed. I mean JDK. Then environment variables if we have to define.
Let's say my QA is my target environment one. Okay, in this QA environment, I want to run the application, same application. That means what are the WAR file he has created, you want to run it here.
You need to have the server to run that application, like Tomcat or something.
Okay, so it means the requirement here is we need to have the Tomcat server. The same Tomcat server should be installed here also, correct? And to install Tomcat, we need JDK and then Tomcat. So once you have these two tools in place, we can run this web app. Similarly, the next environment, even QA environment, sorry, UAT environment, the same set of tools should be available. Now, assume that the developer who's using the local machine is having something like JDK 1.8 and Tomcat 8.5. With these two tools, he can able to run this application successfully. But in a QA environment, they have just OpenJDK 11 and Tomcat 8.0. And similarly, in UAT environment, they have something like JDK 17, assume it, and then it is a 10.0, assume it. So can I able to run the same application in the target environment?
No.
No.
What will happen now?
It gives an error, I mean mismatch compatibility of the.
So this will throw a compatibility issue, right? Because only if I run the application, I can able to do the testing. But problem is, I'm unable to run the application because of the compatibility issue. Correct. So this is not the problem from the developer. Developer, he has done the testing, his code is ready. What are things he has tested in local environment is working as expected. So now this issue is not because of the developer, it is purely depends upon the infrastructure, right? The tools related issue. So who's going to take a responsibility of this? So in a
DevOps
legacy,
team.
no, not in DevOps team. So the process is, it is a responsibility of the development team and the testing team to sit together and understand their requirements, what type of application they want to execute, and to execute the application, what type of tools they need. And these tools has to be installed in the target environment. So both the teams will sit together and finalize the approach, and that will be sent to the infra team. Infra team will install the required tools in the target machine environment. Here, DevOps team is not going to play any role because it's the infra team is going to configure the server, right? I get your point. So if it is a monolith application architecture, there is no problem because there is only one application which can be developed and it can be built and deployed in all the higher environments. In all the higher environments, I can have one version of tool. That's fine. But in a microservice-based architecture, a developer can able to create a number of services, right? So no. And each and every service might need its own tool stack. Correct? Guys, are you getting my point? Each and every service might need its own tool stack. Let's say my app web application 1 is needing this Java JDK 1.8. And this another service. Assume that this is running in a different version, like OpenJDK. And 8.7, something like this. So like this, I have thousands of microservices. Each and every service has its own tools stack. And I can't expect my infrastructure team or the testing team to keep the tool ready in their environment. It's not possible. It's not that easy. So how are we going to handle this situation? How are you going to mitigate this? For that purpose only, we're going to use a concept called containers. So it means if it is a containerized application deployment approach, we are not going to directly copy the artifacts to the target environment. So once the developer done with the testing in the local environment, what they do means they just create a package out of it. So this package contains the application along with its dependencies. And it will be given a name like my web app image 1. That's it. Or I can select package 1. Similarly, if he's creating another application, means for that application also he'll be creating another package. It will be for 2. And this is OpenJDK. And this is with 7, for example. Easy. So now once a package is ready, that package will be promoted to the target environment. So we're not going to directly copy the artifacts. The deployment here, it is going to deploy the package. So now in QA environment, instead of deploying a WAR file, we are going to deploy the package like this. So now this package already contains the application along with its dependencies. So in the target environment, even if the tool is not installed, even if it is just a simple VM without any tool, your application will be up and running because it is already having that dependency with it itself. Are you getting my point now? Can you able to understand the difference?
Yes.
So this is what? So ultimately, here containerization. Means it is a process of packaging the applications along with its dependencies. That's it. So here the
Okay, if
application is
we
my web app
one
one
doubt.
var, and this is the dependency. So this can be packaged together, and it will get deployed. And in containerization, we never use a term called package. We use a term called image. The package is also considered as an image here. Got it? So whenever I talk about the image is nothing but it is a package of my application along with its dependencies. And when you talk about deployment, this image will be deployed to the target environment for further execution and testing. Any question?
Yeah, the package will be created only we have run our application in the containerization, right? In
Yes.
Docker.
If you want to deploy your application using containers, that image has to be created. Are you getting the point now? Guys? Confusing.
So once the image is there in testing environment, let's say QA environment, so how we can run that image?
That is secondary. First, we'll see how to create it. What is the purpose of it? Then we'll go to the next level. We have to do a lot many things before that. You understood the core functionalities, right? What is the purpose of containers?
That I got it. Yeah.
This is what. So how to create it, how to deploy it, and how to run it and all, we'll go step by step. Don't worry. So this is how you can able to now understand the purpose of containers and containerization on both infrastructure perspective as well as deployment perspective. So in order to work on this, you need to learn many things. The very first thing is about the contain terminologies. So there are various terminologies associated to this module. So very first thing is you should understand about the container engine. And next thing is about the image. And then containers. And then container registry. And next thing is about the repository. Right. Like this, there are a lot of terminologies associated to this module. So what does container engine means? It is used to create, run, or manage the containers. Got it? It is used to create, run, or manage the containers. I'll talk about how to use it, what are the commands associated with all those things. And the images. Images are nothing but a static file. A static file that defines the, or I can say like composed of various layers that defines the dependencies. Right. So it is just a static file. Static file in the sense it is non-executable. So it's a very important point. Images are composed of various layers. Each and every layer defines the application and its dependencies. Let's say for this particular application, or for the, assume that this is one image I said, right? So I can simply term it as image instead of package. Package is also very old. In the very initial versions of containers, we use a package, a term package, but now we refer it as image. So now if you see here, this is an image which composed of 3 different components. One is the application, JDK, and then Tomcat. So how these things are defined means by using the layers. Each and every definition will be having its own layer. So I'll show you tomorrow. I mean, once we start with the implementation, I'll show you how we can able to create the images, how to explore it. And containers. Containers. The executable unit of container image. So as I said, image is just a static file which is non-executable. It's just a file. As like you can see, if you are talking about a Java program, you can open a notepad and create a Java program, right? Hope you and save the file as a Java, astic.java. So that file is just a static file which is non-executable. So how to make it as executable component? How to run the Java program? Guys?
In command prompt, we'll give like Java, JDK,
Whatever it is. So
with
that
file name.
that
Yes.
program has to be converted to executable component. Like if you create a class file out of it, right? Only that is executable. Correct. Once you compile the program and when it creates artifacts, then that is executable. Similarly, here, an image is just a definition of your application and its dependencies. If you want to execute this in the target environment, it has to be converted to a container. So containers are the executable unit of your container images, whatever you created. All right. So what are the commands associated to this? How to create a container and how to run the container in a different mode that we'll see while you progress. And another important thing is about the container registry. So this container registry, it is used to store and manage the container images. Let's say, for example, consider I have created one image. This image is a static file, which is composed of various layers. So once it is created, where I'm going to store it? It should be stored in a common repository or a common environment from where anyone can able to access it. That's what we call as a container registry. Let's
Like
say,
I
for
know
example, consider
container.
in your source code management, we have something called GitHub repository, right? So what is the purpose of GitHub repository? GitHub repositories are used to manage the source code, correct? Once the developer done with the code in the local machine, they just publish the source code to the GitHub repository, and from there only we just picking up for build and deployments, creating artifacts. Similarly, once the image is created, that image will be stored in the container registry. So one of the popular container registry we use is Docker Hub. So using Docker Hub, we can able to store and manage the container images. So whenever we talk about deployment, let's say in this example, I told you developer will create the image and that image will be deployed to the QA environment. So directly we never move the image from this machine to this machine. All that we do is we'll be having a container registry. So developer will publish that image to the container registry, and from container registry, it will be downloaded to your QA environment. That's what. It's just a common or centralized environment where we can able to store the images. And this is a subset. You can consider a container repository as a subset of container registry. Let's say I have a registry and I just want to have different levels of registry means I can create a repository for each and every team or application. It depends. So I expect everyone to create an account in Docker Hub. Okay, if you want, I can show you that link. So all of you right now, okay, you can log into this account. I mean, let me ping you this link. If you already have, that's fine. Ensure that you can even log into that account. hub.docker.com. So if you log into this account, I mean, you can able to access the images which is already available. So please use this link to create an account. You need a valid email ID. Once it is done, just do some sort of verification and validation of your IDs and all, and then your account will be up for active. So we'll be using this Docker Hub to maintain and manage our container images. We'll talk about it. We'll talk many things about that, but before that, please try to create this account. Are we on it?
So in case of a container, let's say developers, use that the package and its dependencies, right? And push it in that. Is it feasible like they push it in on GitHub and then we fetch it from there and deploy it on QA server?
See, ultimately, your GitHub is not meant for maintaining your container images or artifacts. It is meant only for source code repository.
Okay.
Right. So in SDLC process, we have a source code management tool for managing a source code. We have the artifact libraries like JFrog artifacts to manage artifacts. Similarly, we have something called container registry for managing the containers images. So are we creating this account now? Please confirm.
Yes.
Guys.
Already have it.
Okay, if you have it already, then you can simply log into that. Ensure that you can even log into that. Want to have break or you can continue? Okay, no problem. Guys. Hello. Why there is no interaction? What's happening?
I think
We need
some
break.
break will be good.
Break would be nice.
Because that's what I can see very low voice from you people. I thought VMs and all it's going above your head. Huh?
Yeah, I know.
All right, then carry on. If you want, you can avail break, refresh yourself and come back. We'll play with containers.
Okay, sure.
Yeah, go ahead, please.
Sai, I am back.
So shall we?
Sure.
All right. Thanks for joining back. So let's proceed with our implementation. So by this, you should know what is the need for containers, what is the difference between VM and a container, and what are the terminologies we have, right? So in order to start working on this, there are some prerequisites. First thing is we should have a valid account.
Hello. Sai, your voice is a bit low.
Hello, I'm audible now or?
Yes, now perfect.
Yes.
Okay, thank you. So now we have a Docker Hub account. Hope you have created account now or anyone need to create? Anyone need to create Docker Hub account? I pinged you the link, right?
Yes.
All right. So please ensure that you create an account and you should be able to log into Docker Hub. First thing. Second thing is we can able to install Docker engine. So earlier I was talking about a container engine, but now I'm very much specific on Docker. Why? Because there are various types of containers available in market. Okay, various types of container engines available in market. Out of the Docker container engine is one of that. So using Docker container engine, we can able to create the images, we can able to create the containers, and we can run and manage the containers. Got it? And also we can able to interact with the container registries. So once it is installed, then you need to work on some Docker CLI commands to interact with the container. Like I was talking about the image creation. So how to create an image, how to run the container. All those things can be achieved with the help of your container CLI. Right. So apart from this, in general, you need to understand few things about the container engine. Let's say, for example, we are using Docker container engine. So this is one of the open source tools. It is the open source container engine, which anyone can able to download and install on the local environment, and they can able to create their containers as per their need. And this container engine uses the underlying property of the operating system like CG, control group. And what else? Namespaces. So these are the two important properties of kernel. To create and manage and run the containers. Correct? That matters. So apart from this open source, I said it is open source, right?
Yes.
Open source. So this open source container engine is configured with the container registry called Docker Hub. Okay, it is a container registry. So anyone who wants to quickly create the containers and run the containers, they can able to use this Docker container engine. And the images, whatever they created using Docker container engine, if they want to maintain it in a common repository environment, they can use this container registry. So apart from open source, they have something called managed services. Like each and every service provider, like if you're talking about AWS or Azure or your Google Cloud platform, each and every service provider have their own container service, which are paid version. Okay, you need to pay some extra dollars to avail those services. So like, for example, here you have AWS means we call it something like Elastic Container Service. And they have a dedicated container registry like Elastic Container Registry. Similarly, this guy, Azure is also having Azure Container Service and Azure Container Registry. And Google is having another thing called Google Container Service and Google Container Registry. Like this, each and every service provider have their own product to manage their applications, container and the container registries. It's all paid versions. And apart from that, there is something called container orchestration tool. Okay. There's something called container orchestration tool. It is used to orchestrate the containers and ensure high availability of containers. Got it? That matters. So what it mean here, as I said already, the containers are meant for running some applications. Once the application or task completes, automatically container go to exit state. It is not after the execution of container application, even while applications are running due to some interruption, okay, or due to some malfunction, the container will go to exit state. So let's say, for example, consider I have a production application. I have the application that is running in production environment, and I'm running the production applications in a container. Like, for example, assume that I have a microservice. Microservice. So let's say we have various microservices, like already we gave some example, right, for e-commerce portal, no, remember? So what are the services we can have here? Like I have something called payment mod service, or something like sign in. Right? So let's take one example now. So what type of application this can be? Like a sign in service? It can be 3-tier application or 2-tier. Guys?
It's a 3-tier, I think.
If I talk about the sign-in module or a sign-in application service, what kind of application it is? Is that a 3-tier application or 2-tier application?
It will be 3-tier, I think.
So 3-tier means this includes your front end, your application logic, and then your backend, that is your database. Correct. Guys, listen carefully. It is a very core concept in DevOps, actually. Please pay attention. So now point is, I have a 3-tier application, which is configured with all these 3 layers. So all these 3 layers are responsible to run my application, correct? This particular service at least. So if I'm talking about the simple deployment, what I'll do, I'll be deploying this as a WAR file in my target environment, and directly in the virtual machine, all these things will get up and running. But if it is a containerized application, I'll be having the containers for each and every layer here. Like for front end, I'll be having container 1 for application logic and database. So these 3 containers are responsible to run this service. Because my application, the front end, it can be my JSP page or HTML page, or whatever I created for sign-in user interface, it is running in this container. Similarly, application, it can be my Java application or core .NET Java, .NET C# applications. It is running in this container, and this is my database. It can be MySQL or Oracle or Postgres. Like this, each and every component has its own container to run its application. Now, out of these 3 containers, if any one container is down due to some reason, what will happen?
That respective microservice would be...
Yes, it will impact the entire service. Even if one container is down, it will impact the entire service. So how to ensure high availability of the container? For that only we use a concept called container orchestration tool. Got it? So container orchestration tool helps to orchestrate the containers. That means more than one containers can be combined together and it can be executed for a service. And also it helps to ensure high availability of the container. Even if it goes down, immediately it will create a new container with the same configuration and ensure that the application is up and running 24/7. So if you're talking about Docker, means we have a container orchestration tool called Docker Swarm. But the limitation here is Docker Swarm is meant only for Docker containers. It is used to handle some limited workload. Got it? But if you want to work on some core production related things, and if you have thousands of microservices to be deployed in a very short time, you can't rely on the Docker Swarm. So for that, we use a concept called Kubernetes. So ultimately, Kubernetes is also a container orchestration tool. And when compared to Docker Swarm, Kubernetes is having a lot of capabilities when it comes to the availability and when it comes to the load balancing, auto scaling, and all. A lot of things. We'll talk about it while we start once we start with that module. So point here is it is not just about the container, it is also about the availability of the container. Got it? Because in a production environment, if I implement a containerized deployment and if all my application workload it is relying on container, means the container should be stable, it should be reliable to run my application. So in order to ensure that level of availability only, we use something called container orchestration tool. So this Docker Swarm and Kubernetes are also open source container orchestration tool. Got it? Docker Swarm and Kubernetes also considers an open source container orchestration tool. And as I said, your service provider will be having some managed service, right? Similarly, we have some container orchestration tool like Elastic Kubernetes Service and Azure Kubernetes Service. And this guy is having Google Kubernetes Service. Actually, Kubernetes was initially owned by Google. I'll talk about it. Once we start with Kubernetes model, we'll talk about that in detail. So all you should understand here is what are the different types of containers tools available and which is open source tool. And when it comes to managed services, what are tools available? And what are the things they are going to provide? Because it is not just about container service, right? It also includes the container registry and the container orchestration tool. Any question here? Guys? Any question?
How can we define this Docker? I mean, in like, technical terms, Docker is containerization orchestration tool, right?
No, Docker is not an orchestration tool. Docker Swarm is an orchestration tool.
So Docker, how can we define?
Let me put it here. Okay. So while talking about the terminal itself, I told you container engine, right? And whenever we talk about the Docker, it is a container engine. We are just referring to the container engine. Using Docker container engine, we can able to create the Docker containers. We can able to create Docker images, and we can able to run the Docker containers. Got it? Like we have Linux containers, Linux container engine. Apart from Docker, we have something called Linux container engine. Similarly, we have something called Google container engine. Like that, there are a lot of if I say something about Docker container engine, means it is meant for managing the Docker containers and images. Similarly, if I talk about Linux container engine, means it is meant for Linux containers and images. So a vendor varies actually. Similarly, if I talk about your Azure container service, means it is meant for containers and images created and managed within the Azure environment. That matters. Got it? So as far as the terminals are concerned, you should know what is a container engine, image, container, and all these things are generic one. If you include your Docker means, then this becomes a Docker container engine. Similarly, if I say Docker image, it is applicable. So I'm just giving you some generalized input so that this can be connected with any of the available container tools in market.
So apart from Docker, what are the other container tools, Sai?
Come again? I told you, right? We have Google Container Engine. We have a Linux Container Engine.
Oh, they're all called Dockers then.
No, not Docker. Docker is just one of the products.
Yeah, the vendors.
Okay, just one of the products. Like we have something like Linux means it is meant by the Linux. See, containers are, first of all, containers are not something new actually. Okay. Docker, they introduced Docker in the year around 2013. 2030, when Docker was introduced, by the time only the containerization and the microservice architecture, the deployment, all it does, speed up their implementations. But even before that, even before Docker came into market, we have the container technology available. 30, 40 years back itself, we have this technology available. It was maintained for core business applications. Even before that IT, I use a term called package, right? Initially, we never use a term called container. It is referred as a package that was used during your telecommunication. If you're aware of telecommunications and all, we use some terms called packet switching and all, right? Packets. Are you aware of the terms? Like
Yeah, packets. We have.
yeah. So let's say during a telecommunication, right? They send some packets from the source to destination. So the packet contains the message along with source ID and the destination ID, right? In the telecommunication. So that is what the evolution. That is how the container was introduced in this deployment level. Got it. And even before Docker, we were very frequently using Linux containers, LXC. And that is very much effective. But when compared to that, Docker is very simple, very easy to use. And it is open source, which helps to quickly create the containers, create the container images, and quickly deploy and run it. And it also helps to effectively manage the resources. All right. Are you getting a point, all of you? Shall we go with the implementation now? Guys?
Yeah.
Any question? Please let me know. Fine. So first I'll talk about the Docker Hub. Then we'll talk about the installation other stuff. So I believe already you must have created an account here. So this is what the Docker Hub account. Okay. Once you log into Docker Hub, you should be able to see the Explore button. So from this Explore button, you can able to see the list of images that are already published by the Docker community. You can see here, right?
It's asking to download the desktop application. Do we need to download or not?
Don't need to download now. Just create an account. That's enough.
Okay. Thank you.
So here we have something called images. Like we have images for each and every tools and services. Let's say we discussed about Tomcat, right? I can able to see the Tomcat image available. So in any virtual machine, if I want to quickly execute any Tomcat application, using this image, I can able to quickly run the application. I no need to manually go and install JDK and create an environment variable and start or stop the Tomcat server. It's all running through a container. So Tomcat is one application that are packaged and published to Docker Hub as a image. As I said, image is a static file. So for example, if I get into this particular Tomcat image in Docker Hub, you can able to see there are various versions of Tomcat. This is the latest version. And from this tags, you can able to see the list of versions, which is already available for usage. So if you explore any one of these versions here, let me take the latest version. See, as I said, images are a static file. composed of various layers that defines the application and its dependencies. And it is non-executable. So if I am talking about Tomcat, means it is the image, which is a static file composed of various layers. So these are the layers of your Tomcat image. Layers means each and every changes you made in that particular image are created as a layer. Let's say, for example, in your VM, if you want to set up a Tomcat server, what are things you will do? Your requirement is to set up a Tomcat server. What are things we need?
We are downloading the prerequisites, like the dependencies, and after that we are installing Tomcat.
Point is, first you need a valid operating system in which OS you're going to run your Tomcat. And on top of that operating system, you need to install JDK. And then you need to create an environment variable for JDK. And then you'll be downloading Tomcat. And once the Tomcat is downloaded, you should be able to map it to your JDK by using environment variable. And that Tomcat should have a valid port number exposed, that is port 8080. And then once all these things are satisfied, then you'll be starting the Tomcat server, right? Yes or no? These are the activities involved to set up the Tomcat server. So all these things are defined in the form of a static file here in the layer. So if you look into the layers of this Tomcat image, you can able to see on the base operating system, they have installed JDK and they have created some environmental variable. env path means environmental variable. And then they just downloaded the Tomcat, exposed the IP address, port number to 8080 and started the Tomcat service. So this is how we just create the layers of image. Once it is available, you can quickly run it in your local machine to start the container. I'll show you how to do that and all.
So basically these layers are simplifying the creation of the Docker images, isn't it?
Creation of the Docker image, you mean? No, this itself, it's an image. The image means, see, if I talk about a HTML file, what it contains? HTML file contains HTML tags, right?
Correct.
Similarly, this is an image file. It is a file that it is a static file that composed of layers. That's all.
Okay.
Each and every action you do, let's say if I install Java means it is one layer. If I create environment variable means it is one layer. Like that, each and every task you do, everything is considered as a layer.
Okay, for every action, it will create layer by layer.
Yes, correct. That's right. Even tomorrow, if you want, you can able to customize this. You can able to add more features also. So you can able to add your own layers there. It's possible. Fine. So now we have the images, and from your Docker Hub registry, I'll show you how to download Tomcat in coming session. Let's understand the interface, the dashboard of this Docker Hub. So first thing is the trusted content is very important. So by default, you can see there are some Docker official images. The image name is Alpine, which is tagged with Docker official image tag. This is a certified image. Similarly, this Nginx is a certified image. So as per the best practice, whenever we try to use any image from the Docker Hub registry, it should be a Docker certified image. That's what the recommendation. Apart from certified images, we have something from the verified publisher or from open source community. Got it? So we can able to refer that also, unless it is free from malwares and vulnerabilities. Like if you take any of the images, you should be able to see the image details. Which talks about the vulnerabilities and other stuff. Correct. So if you look into this, this is one of the image from the verified publisher. It is not having that much documentation, right? It is not having that much full information about the tool stack or the versions, whatever it uses. But instead of the verified image, if I search for any official image, like Docker official image, like Nginx, you can able to see it is a completely documented, right? What does that image is all about, and for what purpose you use it, how to use it, what are the commands you use, and if any issues occurs, how you can able to troubleshoot it. Everything, it will be properly documented. And another important thing is, if you take any of the versions, it will be identifying all the layers in detail and also vulnerabilities. So this image is not having any vulnerability. It is free from vulnerabilities. So that is why. So that is the reason always it is recommended to use the Docker official image in real-time environment, which is having a proper documentation and regular version updates and patch updates, and it won't have any vulnerabilities. That is what the basic thing. Easy? Is it clear to all? And similarly, tomorrow, if you want, you can able to create your own image and publish it. That's also possible. Once you publish your image, it will be available in the repository. Like based upon a repository name, the image will be published there. I'll show you once we create image, I'll show you how to do that. So this is just an introduction to your Docker Hub. Now let's work on some container techniques. Let's say we'll go and install Docker Engine first, and then we'll work with the CLI. So let me log into my AWS console first. I think we already have our Jenkins master.
Sai, are you sharing the?
No, I'm just logging to my AWS console now.
Okay, but it's not sharing.
Yeah, let me log in. Okay, so I just logged into my account. So now I think we already have a Jenkins master and Jenkins slave node, right? Guys?
Yes.
What is a DR? Okay, so I'll do one thing. I don't want to create a new VM for Docker installation. I can use the existing VM for that purpose. Let me use the same machine. Let me start this instance. I'm going to install Docker in the slave machine, okay, in the slave node. Okay, so let me log into this machine. All right. So we are going to talk about the installation and some of the miscellaneous Docker commands. Okay. So first thing is, let's try to install Docker. So please pay attention. Don't try anything there. Listen, please. So in order to install Docker, all that you can do is just log into your account. Log into your machine. I have installed this in my Jenkins slave node itself because already I have the server. I don't want to invest one more server. Even you also can do the same thing. Just log into your Jenkins slave machine and install Docker. So for that, let me first update the system packages. And I'll show you the official documentation from where you can able to install Docker, get the Docker packages and all. Okay. So this is the site, okay, from where you can able to get more details about Docker installation. So if you want to install Docker, you can able to install it on your Linux machines or Mac or Windows. There's no issues. Even people who have created account, you must be getting an option to install a desktop for Windows, right? This is what it is. So you can able to download and install on Windows machine or Linux or Mac. And depends upon distribution also, you can able to take a call. Like if it is a Debian or CentOS, you can able to run some packages like using apt package manager, you can able to install it. So like we are on Debian Ubuntu means this is what the command. You can able to run docker io apt install docker.io. This command will install Docker. So I'll just show you now. It's very easy. Installing Docker is a very straightforward thing, as like you install Git. So once you update the package, just give a command apt install docker.io. apt install docker.io. Just downloading and installing the package. Easy. So once it is installed, it is making as a startup service, so that whenever we reboot your machine or restart your machine, automatically Docker service will get up and running. That is Docker engine. So now if we say Docker version, you should be able to see the Docker has been installed.
Sir, your voice is low.
Hello, what's happening? Guys, still?
Yeah, now it is okay.
Okay. So Docker version 24.0.5 is the latest version installed. And also if you say Docker version, you can able to see the Docker client, the API, whatever we have you associated to that thing. And this is the server engine, Docker engine version, right? So this is just to ensure that Docker is installed and up and running. Docker version. And apart from that, there is something called system. So this will be the very frequent command which we use to verify the status of the Docker engine, whether it's up and running or not. Because sometimes, application will get deployed and we might not get a response from the application. So development team or testing team will keep on raising a ticket stating that their applications are not reachable. So in any target machine, if the applications are not reachable, first you should diagnose a thing, like what is the root cause of it. So the container engine, which is responsible to run the application, whether the container engine is up and running or not, that matters. So this Docker service should be up and running in all the target environment. That is the very first thing you should do. Once it is up and running, then you can able to validate your application level things. right? So this is about the installation and verification of your Docker engine. So once it is done, now let's go and create some images or containers. So there is a command called Docker images command. So this command will get you the complete list of images that are available in local machine. So as of now, we don't have any image because we just installed Docker. But in the future, whenever you download any image from Docker Hub, or if you create your own image, it will be listed using this command, Docker images command. And apart from that, there is another command called Docker PS command. So this Docker PS command is used to get the list of all the running containers. Consider I have a container, and if you want to get the list of containers that are already up and running, you can able to get these things. So this is also a very much handy command, because tomorrow once the response is not available, you can quickly check for that, whether the container is up and running or not by using this command. And this command will get you only the list of running containers. If any containers that go to exit state or stop state, it won't be available in this list. So apart from this, if you want to get the list of all the containers, whether it is stop state or running state, if you want to get the list of all the containers, you can use -a argument. So this also will get you the complete list of containers. All right, so these are some basic commands you should keep in mind, like we have Docker images or images list, both will be fine. Docker PS, Docker die, Docker PS -a. Correct. So this is about it. So now we'll see how to use or work on the images and containers. So first I'll try to use the images that is available in Docker Hub. We'll go to Docker Hub and try to pull some images and try to run a container out of it. Once we are comfortable with the fundamentals, then I'll show you how to create our own images and publish Docker Hub. Is that fine? Guys?
Yes.
Yes, sir.
Okay. So here is the Docker Hub. Okay, so which image we can use from here? Let me search for some OS related images like CentOS, for example. In my slave machine, the base image is Ubuntu, correct? Base OS is the Ubuntu, correct? The slave machine is running with Ubuntu OS. Now I'm going to run one container that is going to use CentOS. There's CentOS image. So if you want to work with CentOS container, first you have to get into the container image. So this is a very simple command. They're given docker pull CentOS. So this command will download the image from Docker Hub into your local machine. So docker pull CentOS. Can you see this? So this is just an image name. CentOS is the image name, which will download the latest version of CentOS image. If you want to download any previous version or any other version, you can use a tag associated to the image name. Let's say this is the image and this is the latest image. So the latest image can be downloaded just by using the name of the image. That's what they never use any tag here. But if you want to use any previous version, that image name should be associated with the tag number. Got it? So if you want to add a tag to your image name or refer the image version using some tag, you can use image name followed by colon and the tag number. like this. Okay, it's very important. So if I say something like latest, it's same. It is going down to the latest image. So pull command will download the latest version of that image or any specific version of the image from Docker Hub into the volume local machine. It's done. So now that it is downloaded successfully. Now if I say Docker images list, I should be able to see the CentOS images downloaded. Easy. Is it clear? Any question here in downloading the image? Okay. And once the image is downloaded, if you want, you can able to run that image. Okay, like for example, we have something called Docker run followed by the image name like CentOS. So this command will simply run that image because image is just a static file, which is non-executable. If you say Docker ps-a, it has not executed any container as of now. We just download a static file in my local machine. If you want to run it as a container, what you can do means you can simply say Docker run followed by the image name. So this Docker run command is used to create a container based upon this image name. And it runs the container. See here, Docker run CentOS. It has executed. If I say Docker ps, it's not running. But if I say Docker ps-a, it has started one container using the CentOS image. It started created 13 seconds ago and exited in 11 seconds. That means within a second, it went into exit state. Correct? We just started the container, but within a second, it went into exit state. So what could be reason here? Why it is not running?
There is no task to do.
Yes, exactly. So that's what the basic property of a container, right? If you remember, containers are basically used to run the application or a task, not to run an operating system. So CentOS is the OS image. Got it? And if there is no task associated to that container, it will immediately go to exit state. That's what it is happening here also. So it started the container, but there's no task to execute, so it immediately into exit state. It is not going to hold the resource. Easy. So the list, container list will be having container ID. This ID will be uniquely generated whenever you run the container. And this is the image which is associated to the container. And it is the last executable command which is associated to the container image. And then the name, this name is something randomly generated for the container. If you want, you can give a name also. That's not an issue. Any question?
Yes, we are in Ubuntu image, right? We are installed in Docker image as a CentOS, right? In this CentOS, like how
Can you
can
please
we
come again?
install?
We are on
We are on Ubuntu, right?
Ubuntu is a base OS. It's not
Yes,
an
yes.
image.
We have installed this CentOS image from Docker, right?
Yes.
After in this CentOS, like how can we perform task? Like
Yeah, that we'll see. That is what we're going to try now. As of now, just a base OS, right? Without any task, right?
okay,
So
okay,
you can able
okay,
to run the container, and we can able to see how to interact with the container, and we'll start creating a task.
okay.
So not only for CentOS, even you can take any images for that reason. Like if you want to run a Ubuntu, see we have Ubuntu image available here. So how to download this image? What's the command to download the image?
Docker pull.
Docker pull Ubuntu. So when you execute this command, it will try to download the image. But if your intention is to run means directly you can able to run it. Let's say as of now I have only one image. So I can simply say Docker run Ubuntu. So when you give this command, first it will try to search the image from the local machine. If it is not present, then it will try to download from Docker registry and run it and create a container out of it. So Docker run Ubuntu. I'm directly giving a run command with a pull command. See, it is unable to find the image in local machine. So it is trying to pull it from the registry. So pull complete and the execution is completed. So now if I say Docker PS or images, that image should be available here. Ubuntu image is available. And also if I say Docker PS, it is not running because it's just a base OS. But if I say Docker PS-A, I can able to see the latest container got created using Ubuntu image. And within a second, this image also went into exit state. So are you understanding the property of the container now?
Yes.
So container needs a task to perform. If there is no task, then the container will automatically go to exit state. And whenever you run any container, it generates a unique container ID and it is applicable within the machine. Easy? Okay. So like this, there are a lot of containers available as per the need. A lot of images available in Docker Hub registry. As per need, we can able to get into any of those things. That's not an issue. Now, what are the commands we've seen so far? Docker, pull, Docker, run, pull followed by the image name. Image name. Like this. Okay. So now we are going to discuss about something on the mode of execution. Guys, if you find it boring, let me know. I can give you break also, but don't be silent, okay? It's really disturbing. Are you able to understand the workflow or able to follow this or want to have some break?
No.
It's completely fine.
It's
All are good, right?
Yeah.
Yes.
Because people are silent, I feel like whether I'm on right track or not, I'm not able to judge here. So if you have any problem, just stop me then and there and let me know if you have anything I can clarify it again.
Yeah, sure.
All right. So next thing is about the mode of execution. Like what are the various modes to run the container? That's very important thing because only then we can able to leverage the containers and its actual benefits actually. So first thing is we can use Docker run command to create a container. So this run command will automatically create a container and runs the container. So there are three different modes of, and run command will be always associated with the image name. So there are three modes of execution. One is container will run in a attached mode, or it is also called as foreground mode. Second method is it runs in detached mode, or what do you call that? Background mode. And apart from this, we have something called interactive mode. Correct. So there are three different modes of execution. One is attached, detached, or interactive. Attached mode, detached modes, or interactive mode. So how to use all these things? What are the commands? How to execute this means? Let's say if I use a container, then I mean image with the CentOS and all, you will be finding very difficult to trace the things. So what I'll do, I'll be adding some commands while running the container so that it'll be easy for you to track the changes. So let me get into this. So if you see a Docker ps-a, it has executed the container, but it is not having any task. It is running in a bash mode, that's all. This container got executed in a bash mode without any task. So what I'm going to do is I'm going to introduce some task here. So let's say Docker run. First, so I can simply say Docker run CentOS, followed by the command. Any command I can able to give, like sleep 20 or 30. Sleep is a simple Linux command which will hold the process or task for certain duration. See, it is running in a foreground mode. Whenever you run the container in a foreground mode, the terminal will be locked by the container till the task completes. So in the meantime, if I create a duplicate terminal, and if I say Docker ps, I can able to see the container still running. 21 seconds over. 28 seconds. Now it's completed and I got the control back in this terminal. I repeat, let me run the container for 20 seconds. Initially, if I simply say Docker run CentOS means there is no task to execute. That's why it immediately go to exit state. But now I introduce some task like sleep for 20 seconds. So for 20 seconds, my container will be up and running. But till it completes the task, I can't access the terminal. Why? Because it is running in foreground mode. That's the reason I just open a dummy terminal and trying to get the status here. See, this container is running with this command. Started 9 seconds ago and completed 8 seconds and 17, and now it should be over. Easy. So this is about your container running in attached mode. Got it? Similarly, if you want to run it in dash mode means you can able to use a parameter called -d. -d is used to run the container in detached mode. See, it is here, and I can simply say Docker ps. I can able to get the status here. It means the container, whatever we have created, it is running in the background mode. While the container is running in background mode, you can able to access the terminal. There is no restriction there. Only the attached mode will hold the terminal, but your detached mode will just free up the terminal for further access. So in order to run the container in detached mode, we can use -d parameter. Got it? So by default, whenever you run any container, it will run in attached mode. So that is a very important thing. Easy. So this is the default mode of execution because we never use any argument, but it's still running in attached mode. That's what it is, default mode of execution. If you want to explicitly run in background mode, just use -d. -d for detached. Similarly, if you want to run the container in an interactive mode means we want to log into the container and do some activity. Like I want to see the container system or file system, everything. So for that, what I can do, I can simply use a term called -it. So let's say, for example, I can use the same command here, but I'm not going to use any sleep command. Let me directly use -it. That's it. Docker run -it CentOS. See here. -it means interactive terminal, T for terminal. So now if you noticed, I just started the container interactive mode. This is a container ID. So from the host machine, now we are inside the container. If you see the status, this container 2A97A0 is a container, it is still up and running. It is running in its bash mode only. This one. So I'm inside the container now. I can able to execute any commands. I can able to install any tools. Like you asked about how to install or access run the task inside the container, we can able to do anything here. So this is just a base image called CentOS. I'm using this image to run it in interactive mode. So now you can assume, like if I simply say like this, I can able to execute any commands here. So once it is available, you can able to consider this as a VM actually, right? Like I have file system, I can able to install Git. It is not part of this image by default. If I want, I can able to install Git and I can able to start using it inside the container. Similarly, if I want to use this container for my Maven build, I can install Maven. Or Tomcat means I can install Tomcat. Like that, we can have the base image, we can run it in interactive mode, and we can able to perform any sort of task there. Once the task is over, you can simply say exit. So control will come out of the container and go to exit state. See here, it's done. Easy.
So inside the container, I mean, once we go in the container using -it, then we can install the
Any
application.
required, yeah, any
I mean,
application.
with basic Linux command, right?
Yeah, that's right.
So we don't need to give Docker like that.
No, not necessary.
Okay.
See, once you log into your VM, what are things you are doing, right? Similarly, once you log into a container, if a container is based upon CentOS means you can able to run all CentOS commands. Ubuntu means Ubuntu commands. Like that,
Okay.
it is something like, on end user perspective, you can consider it as a VM, but it is not a VM, it is an application running inside the container. Easy. Are we on track? So these are the various modes of running the container. Any question?
Can you come again with the interactive mode?
See, I have an image, right? I have an image. I want to log into the container. I want to create a container and log into the container. So what I can do means I can simply use the command docker run -it. So now it has created one container and the control is within the container. So I can able to explore the container file system, its volumes, everything. I can able to run all sort of commands here. So if you look into this, it is something like a VM which you are running, right? It is like a Linux application or Linux operating system where we can able to perform any sort of task. So this is how your applications are getting injected inside the container. In one of the specific, one of the container volume, we can able to upload the image or application and that can be executed inside the container.
Okay, if we, for example, if you want to install a Python, we just use to that Docker pull Python, or we have to install again Docker in this.
No, here you can able to run directly applications. Within the
Okay,
container, you can run some applications, not again another thing.
okay,
Because to do
okay,
that, you
got it.
again need to have your Docker engine and all, right? So it is not meant for that purpose.
Okay, we
can
can
able to
directly use
install the
any
Python.
direct.
Yeah.
Okay, okay.
So this is the default path, cd space home, where we can install the applications, or
Not like that. You can able to install any path, right? It is just a file system.
okay.
See, let me exit from here. Now I am on my VM, right? I am on my VM. This is my virtual machine where I use some installation path. So if I say ls, I can able to see the file system. If I go to the home and if I say ls, I can able to see this. So these are the list of directories that are available in my file system, right?
Yeah.
In Linux machine. And it is based upon Ubuntu.
Sai, is this CentOS system will be accessible outside?
Complete your question, please.
Are we like able to access this system like CentOS outside the like from the browser or like
CentOS
that?
system or container you are saying, you're talking about?
No, no, the system. If we install any web server in this particular system and we deploy one application, sample application, so can we access that from
See,
outside the
listen,
browser?
please. This is not a CentOS, it's just a Ubuntu machine actually. In my VM, I have Ubuntu machine, right?
Okay.
And on this Ubuntu machine, I installed a container engine called Docker Container Engine. And using the container engine, I just create some containers. So these are the containers I have created so far. It all created and it entered exit state. Can you see this?
Yes.
So like that, you can able to create any number of containers. Like I was talking about this level, right? If you see here, initially when I was talking about this workflow, so like you can consider the same thing I'm doing now. Maybe it is the same, almost you can compare to the same thing. So I have a Jenkins slave machine. It is a VM where I installed Docker Container Engine, and once it is installed, I just created some containers. This is what it is. So let's say I want to run a container. Docker run -it Ubuntu. See, now the control is in Ubuntu machine. I can able to see all the file systems. Like this is my host machine's file system, and this is a container file system. Got it?
Okay.
So as like how I install my softwares in my host machine, I can able to install the softwares in my container also. And I can able to build some applications there. I can able to clone some repositories. Like say after installing this Git, I can able to clone the repository from the GitHub, and I can able to use Maven. I can install Maven here and I can perform the build and create artifacts.
Yeah.
Once artifact is created, I can able to move it to my artifact library to the host machine. Everything is possible.
Okay. Okay. So my question was like you are like entering this container, right? And if we install any web server and deploy one application in this container,
Mhm.
will this be accessible outside like from browser?
Yes, is it possible? It is possible. That's what the objective, right?
Okay.
We'll see that how to do it.
Okay. Okay. Fine. Thanks.
So you are asking about the container, not the machine, right? Host machine.
Okay.
Yeah, it's possible. See, this is about your containers. Okay, so as like you can see, we can able to run multiple containers, and each and every container run it in its own namespace. And once a process completes, it go to exit state immediately. Easy.
So here we have, I mean, can you please go back to that Notepad editor? Yeah. So here, let's say container one is Java application and two is having Python. So in case container two is down and we can't be able to, access this application, right? So in
Yeah.
that case, what would Docker do in that case?
That is the reason we have something called container orchestration tool, right? Hope you remember I was talking about the container orchestration tool. It is
Yeah,
used to
it
orchestrate the
will.
containers and ensure high availability of the container, right?
Okay.
Like
Okay.
Docker Swarm or Kubernetes. So we need to use these features to ensure high availability of the containers.
Immediately. Okay. Yeah. Immediately it will create. Okay.
Got it?
Yeah.
Okay. So this is about the images and creating the containers, right? And running the containers in interactive mode or background or foreground mode. So now what we'll do, we'll see how to delete the image or remove the containers. Like for example, consider I have the Ubuntu image or container that is available. If I don't want this container anymore, I can simply say Docker rm followed by the container ID. It's removed. Now if I say container ps docker ps-a, that Ubuntu container 41BC at the last second has been removed. Similarly, if I want to remove image, I can use a parameter called. I have two images here. If I want to delete any of the images from a local machine, I can simply say docker rmi, I for image, followed by the image name or image ID. Usually we use image ID, which is unique. So let's say I want to remove this Ubuntu image from this machine. Just notice what is going to happen now. So what it means? What happened?
The container is in stopped mode.
Yes. So it means
So
using this Ubuntu image, I have already created one container, and that container is already referenced in this level. It is though it is in stop state, you can't delete that image if there is any reference, container reference. Got it? So whenever the container is in running state or stop state, you can't delete that image by default. Got it? So here there are two options. Either you delete the container and then delete your image, or you can do a forced deletion. Means,
but Sai, that was in exit state, right?
yeah, though it's in exit state, it is referred, right? We can able to start at any point of time, no?
Okay, yeah.
That matters. So docker RMI followed by the image ID. This is for images. Similarly, we have something called docker RM. This is for container. ID. This is to remove the image, and this is to remove container. So if the image is already referred by any of the container, you can't delete it by default. So what you can do means you can use -f. That is remove the container. Sorry, remove the image forceful. That is what -f means. Or delete the container and then remove that image. It should be fine. Hope you're getting a point. So now what I can do, I can simply go ahead and remove that image. Sorry, remove the container. Which container is associated with that? This is the one. And now if I say remove RMI, that image number, it gets removed. So if I get the list of images, Ubuntu has been removed now from my machine. Easy. So like this, we can able to use the commands to remove your images or containers. So not only that, if you want to remove multiple containers or multiple images at the same time, you can simply use this. You can refer first 3-5 characters of the image, sorry, container ID. Like if you want to delete multiple containers at the same time or multiple images at the same time, just give one character space and give the image ID. Image ID no need to be complete image ID because within your machine, the image ID will be unique. So first 4-5 characters are sufficient to identify the image ID. See, these 3 images are, containers are deleted. Easy?
I just want to recall that if container is in start or stop mode, in that case, if we want to remove the image, so first we have to remove the container and then we can delete the image, right?
Yeah, that's right.
Okay.
Easy?
I'm just confused with this image IDs actually. Like, which is image ID and which is container ID? Like,
Confusion should not be there. It should be with the commands. So if I say
Yeah.
RMI means it is for removing the image. If
Okay.
I say RM means it is to remove the container. So
Okay.
whenever you specify RMI, you should use the image ID. Because
Okay, like
using the image ID, you're going to remove the image.
okay, like
For
can you show
remove
me
the
that image
container,
ID and container ID? Like how can we find the difference?
so here, if you
PS okay.
so this is what the container ID. If you give Docker PS-A, you can get the container ID.
Okay.
And for images, you'll be getting the image ID here.
Okay, now I got it. Yep. Thank you. Yeah, I got it, sir.
Okay. Any other question from anyone? Are we good with this? Fine. So apart from there is something like Docker history followed by the image ID. See, the history command is used to get the complete history of that image. It means it's going to get the list of layers that is associated to that image file. So all these things are layers of the image. Let's say, I think that's a CentOS image, right? If you search for CentOS, latest image. See, the latest CentOS image has 3 layers. First is add, label, and then CMD. So at any point of time, through your CLI command, if you want to get the complete history of an image, we can use history command. Okay, history command. This will be very much helpful tomorrow if you want to create your own images and verify the history or layers of the images. And similarly, we have something called inspect command. Docker inspect. So the inspect command is used to inspect or verify the entire configuration of that image or any Docker object. Like I just wanted to get more information about this image, about its ID, its associated parameters, the host name, everything, volume mounts, everything. So if you want to get the detailed information about any of the images, we can able to get this. And not only this, even it is applicable for a container. Like for example, if I say inspect followed by the container ID. See, it clearly gives you the information about the container, a complete architecture level information. Like what is the ID of the container? The ID, whatever you're seeing here, it is just few characters, but this is the actual ID of the container. And when it is created, and what is the path, right? So here the path, I just use sleep command. That's what the path says, sleep, and argument is 20. And then the status of the container is exit state. And which image is used in this container means it is 5D0DA something. It is something but my CentOS image ID. And then the name of the container and its properties, the networking, the port numbers associated to that, especially volume mounts, how much volume is available, how much utilized. So everything will be retrieved from this inspect command. So Docker, what is it? Inspect followed by the container object. It can be your container ID or image ID. Okay. Just a few things here. And sometimes the container will be up and running. Okay, we might get some experience like this. Let's say I have deployed one application in my container and the container is up and running. But due to some logical issue, okay, the program is getting into loop. Chances are there, right? Programs are getting into loop actually, but the application is running inside the container. So how to stop the container means we have a command called stop container. let's say images. So all that I can do is I can run this image now. Docker run for this image ID, and I can simply say sleep for 200 seconds. So what will happen now? If I give this command, what will happen?
It will run the container.
For 200 seconds, right?
Yes, and then exit.
So that's what the problem. So instead of 20, I by mistake I give 200. So it means for 200 seconds it will be holding the resource. So if I say Docker PS, it is still running. Still running. So how to stop this means I can simply say Docker stop command, stop followed by the container ID. It will interrupt the container process. It will releases all the namespaces and the CG, whatever we are associated to that, and just stops the container. See here, I got the control back. Now if I say Docker PS, it's not available. So this is very important thing, okay? Because sometimes if application is getting into loop, it will consume that much resources. That too, if it is of a free tier application architecture, it might hold your database. A lot of things will happen. So unnecessarily, you should not keep your resource holding for any unwanted task. So you can simply go and stop the container. A quick remedy. Easy. The clear. So let's say I have this container in stop state. If I want to start it again, I can simply say start. Started. See? Right? So like this, now we can able to stop or start the container at any point of time. It's running now. The same container. I never use any other parameter. I no need to give run command all. Already I executed some container. Assume in which situation will happen, Let's say I'll give you one scenario. Let me stop this first. I'll give you one scenario. Consider this is one of the containers which I use to perform the Maven application build and create artifacts. Okay. And when I start the container, it will automatically pull the source code from the repository, perform Maven build and create the artifacts. And that artifact will be copied to my host machine. Once it is copied to host machine, automatically the process completes. The container will go to exit state. That's all. Hope you are following this. Now
Yes.
the container goes to exit state. The executed container has already created the artifacts and the artifact is available in my host machine. And this can be published Docker Hub for further deployment. That is fine. Now developer has made some incremental changes in source code. Got it? Developer has made some incremental changes in source code. And again, he want to perform build. So what we can do now? We can simply go and start the same container using start command. So if we start the container, automatically container will start from the scratch where it will pull this latest code from the repository, perform build and publish that artifact to the new artifacts to the host machine. Like that, we can able to write some logic to handle the application. That is the reason we just use start or stop. Easy.
But that's a manual intervention, right? Where we have to start the container and then it will
Just
done.
put in a script and invoke through Jenkins.
Oh, okay.
Correct. Everything. See, we are learning about the CLI, right? So what are the possible CLI commands we have in Docker? That's what we're learning now. If you want to implement through automation, just that is the reason we have Jenkins orchestration tool, right? Any question? All right. Similarly, we have something called log. So basically, what is need for logs?
I think it will show the application. Let's say application get crashed or not installed or some history of Docker container.
Okay. So now if you noticed, I just gave a command called log command, docker logs followed by the container ID. I just executed this logs command in 2 containers. Both are stopped container. So now if you see docker log against this container ID. So when I issue the log command, you can able to see what are the activities I perform on the container. Can you see this? I've just create the container and I execute in interactive mode. That's why I can able to, I gave ls command and I gave cd home ls, everything we did now, right? Remember just few minutes ago, we just created one container in interactive mode and we navigate to that container path and exit it. So the log command will get you the complete execution. What are things you did in the container? It'll be available here. So it's very much important. If you want tomorrow, if anything goes wrong, if any applications are down, sometimes the container will be up and running. Let me show you that once. Docker run command I gave, right? Somewhere. Docker run CentOS sleep for 60 seconds. It is up and running. And now if we say Docker PS, I can able to see this contains up and running. So I can simply say Docker logs followed by the container ID. See here, we are not doing anything. It is just sleeping there. It is not having any other activity. That's the reason we can't find anything. But instead of that, if you move it in interactive mode or if you deploy any application like a Tomcat web applications, if you get in the log, you can able to see the activities what we performed. So that is how we can able to understand what are things you perform on the particular container. Clear? So Docker logs, sorry, followed by the container ID. Easy? Is that possible to digest this or it's?
Yes, I.
Okay. So that is about the Docker logs command, inspect command. And also I think we use Docker stop followed by the container ID. And similarly, we have something called Docker start using the container ID. Correct? So like this, we have a lot of commands associated to this Docker containers.
Sai, there is a query. If we are in let's say specific container, right? So we created that container from the image, and now we are in that container. So from that container, we can create the new image.
Yeah, it's possible.
Vice and versa. Okay, yeah.
Yeah, that is what we are going to do actually. Ultimate role is that is what. No, it is not just about getting the starting or stopping containers, which is already available, right? So we should able to create our own container as per the need.
Okay.
So we'll see how to do that. So the next topic is about port mapping. Or is also called as port binding. So already you must be familiar with Tomcat server, right? Tomcat is a web application server, right? So which runs in port 8080, correct? And using this web application server, I can able to run any of my web application. That's what we did in our QA server, right? In Jenkins module. So what are the things required for this to have this Tomcat installed and deploy my application? How much effort you have used there? Like
Creating virtual machine and downloading JDK.
So you must have launched a VM, you must have installed JDK, and then you downloaded Tomcat, create environment variable for JDK, and then attach to the Tomcat and start the Tomcat server, right? So a lot of things are involved, but all these things can be simplified with the help of container. So going forward, I'm not going to install Tomcat in my VM directly. I want to run it as a container because already I have a container image for Tomcat, and using container image, I can able to directly run the container Tomcat application. But the point here is, whenever you run any application, it is not just about Tomcat, anything like tomorrow you might use Nginx kind of application servers. So whenever you try to run any application inside the container, I told you containers are completely isolated. What are things you are doing inside the container? The next container or even the underlying OS itself will not know about it. It is completely isolated, running completely isolated namespace. But my requirement is, I have an application running inside the container, I want to access it now. How to do that? For that only we're using concept called port mapping. So it means any application that is running inside the container, if it is a web service, means definitely it will be having a port number. That is must to have. Any web application server or any application that is running inside the container will be having the port number. But that port is associated within the container, not at the VM level. So the port which is used inside the container are called as a container port. That has to map to the host port. So for what we do means, we'll be using a command like while running a container, you can simply say docker run -it. It is optional, -it is optional, but the port mapping is important. -p followed by the port number. Let's say 8089 8080 followed by the Tomcat image. So what I'm trying to do here is this 8080 is a container port. -p followed by the host port and container port. So my application image, whatever I want to run, it is running in the port 8080 inside the container. If I want to access it through my host machine, that container port should be exposed to host port. Got it? That will be done with the help of your port mapping using this parameter. So it means P means is not porting actually. Technically, it's called a publish. We are trying to publish our container port or the container application using the host port. That's what it means.
And how can we come to know this host port, I mean application port, whether it's
that is pure depends upon the image. The image, whatever you use, right? That image will be having the definition. Let's say, for example, here in your container registry, if you search for Tomcat, you can able to see the official documentation. It will be clearly showing you in which port it is running, all the stuff. 8080 container port number. Or if you go to your what do you call that layers, image layers, you can able to see. I think this is not the version, it is the updated version, I believe. Yeah, so here in this version you can see expose 8080. That means that container application, whatever running is the container, is exposed to port 8080. So that is the reason we need to get into the image and understand the property of the image.
And say, like, what about host port? Like
host port, it can be any available port in your host machine. So where the container is running, let's say now the container is running in my, what is it called? Host machine, right? Slave machine. So in this slave machine, using a security group, just open the port.
Can you show us like how to open?
See, already we must have done this in our previous module, right? While working on Jenkins and QA server. So this is my slave machine. From your AWS console, you can go to the slave machine, click on security tab, and select the security group associated to that slave machine. And here already this machine, it is exposed to port 8080. Got it? This machine is already exposed to port 8080. If you want, I can edit this and I can able to add a new port. Or I can simply say allow all traffic. This CADA block zeros. So I can able to use any port. I just open all the ports, but in real time, we never do this. Just for sake of demo, I just enable all the port numbers. So this is the way you'll be editing an inbound rule and adding the port and saving the rules. Easy. Are you clear now?
Yes, sir. Yes. Thanks.
So now let's do one thing. Let's go and check for the image. The image, whatever I want to use. Okay. We can use the same Tomcat itself. Let me put it into this way. Docker PS, I think no image is running now. So let me run Docker run -IT -P for the port number. Now I open all the ports. So I have all ports available. I can use any port as per my choice. And 8080 should be the same. I can't change the port number. And now the image name, that is, I can use Tomcat 8.0 for that matter. Tomcat 8.0. So now if you see, this image is not present on my local machine, so it is downloading from Docker registry. And upon download, it will try to create a container out of it because we gave Docker run command. And it is starting the container. See, my Tomcat application server is started. It is started now. It is up and running. So if I say Docker PS, I should be able to see this is a container that got created using Tomcat 8.0 image. And it is the last execute command is run command. And this is a port mapping we did. So 8099 is the host port and 8080 is the container port. This is what is mapped. Similarly, if I say Docker PS-A, you can able to see for our previous containers, we never perform any host port mapping. That's the reason it was not available. But the latest container is enabled with the port mapping. That's why we can able to see the host port and the container port. Now my Tomcat application is running inside the container and it is running in port 8080. If I want to access this application through my web browser, I can use this port number. So normally in a QA server, what we did, we use the external IP address of machine, right? Remember, we use the external IP address of machine.
Yes.
So now in this slave node, Jenkins slave node, I have my Docker up and running. So let me take the public IP address of the machine. And I can use port 80. What's the port number I should give here?
89.
89. Because it is exposed to port 8099. It's not 89, this 99. Correct? You can able to see from the, this is also kind of log. The Tomcat servers, application servers are up and running with all these versions, the tools, depends everything. And inside the Tomcat server also, you can see there is something called web apps folder. You can see here the web apps folder. So tomorrow, if you want to deploy your application, you have to copy the artifact to this particular path inside the container. You can run your application. It is running in port 8080. See, I got one. Similarly, what I can do, if I want, I can able to start one more container like Docker run. What is it called? -p. If I want to test one more application, I can able to have it here. It can be same port also, no problem. If the port is available, you can able to use the same port. Tomcat 8.0, right? Started one more container. Now if I say Docker PS, I can able to see there are two containers up and running. Both are running the Tomcat image, but it might run different applications in different port. So it means in a single machine, I can able to run or test multiple applications or multiple services. This was not possible with your QA server. If you install Tomcat in a QA server, at a time you can run only one application, right? If you try to test another application with same port number, it's not possible because already the port number is used by Tomcat server. Now, the Tomcat is running inside my container. I can able to access it through my external port numbers. So I can use the same thing. Assume that this is one service running in port 8080 and another service running in port 8080. This is a host port, not a container port. Easy. Are you following this or not?
Yes.
Guys, please let me know if you have any query. So what is it? Docker run -it followed by the port 8080:8080 Tomcat :8.0. So what is expected now? What is expected now?
It's not
Conflict because the same application is running on 8080.
Yes, already we have executed one container which is mapped to my host port 8080. So this is a creating conflict. So don't get confused. Okay, the conflict is because of the host port, not with the container port. Just to differentiate that only, I just gave this. If you want, I can use this level 99, right? So in this case, see, so the conflict is because of the host port, not because of the container port. Okay, so please be clear with that point. In my host machine, already one task is running in port 8099. So we can't run more than one task or application using a single port. That's what the conflict. Is that clear? So if you want to run another application, just try different port number. Simply just by running this same command with a different port, it will be up and running. See how quickly we can able to process it. So this is okay, in a test server, let's say consider this is a QA server. Don't consider this a VM Jenkins slave machine. Assume that it's a QA server. In your QA server, you never install Tomcat at the host level, but you install Docker engine and created a Tomcat container. So if you do that, you can able to run multiple applications. You can test multiple services by running this same image, but in a different container. Easy? Guys, can you able to relate the things with real-time scenario now? What I'm trying to say here.
Yes. And can we run two different applications on the same host port? I mean, if we want to expose
That's not
the
possible. No,
container,
that's
no.
not possible, right? See, already this port is being used by this container, right?
Yes, yes. So different application, I mean to say if we
Even
install
if it is different application, it will be running on the port number, right? Host port.
so it will create a conflict.
Yeah, port number should be unique.
Okay. All right.
See, the main objective for running multiple containers is just to run different applications only. This container will be running one application, this container will be running another application. But both things should be having the unique host port. Easy?
So what if we define all traffic in both, but still it's unique? Okay. Should be unique.
Are you able to understand this, guys, everyone?
Yeah, I got it.
Okay. So shall we move next topic, or are we good? Or do you have any other questions here? Guys?
No.
Okay. So the next topic is, you can use the same example, okay, like 8.0 itself you can use for this port mapping, -p followed by the port mapping. Fine. So the next thing is about volumes. So Docker volumes is another important topic. It's a very basic thing only, but nothing to worry. So volume means what? It is just a space or storage or a directory which is needed to have some application content. So whenever we talk about a container, okay, listen please. The containers are basically used to run some application. Ultimately, it is used to run some application. But what type of application it is going to run, that matters. So on development perspective or on release management perspective, we can able to say the container applications can be your what do you call that, monolith application or microservice application, or it can be 2-tier application or 3-tier applications. But on container perspective, there are just 2 types of application. On container perspective, the applications are considered as 2 types. One is stateless application, and another thing is stateful application. So these are 2 types of application exist on container perspective. So what does stateless application means? The application that will not have any trace of execution. That is called as a stateless application. So the scope of the application is it will enter into container. Once you start the container, it runs and exit. It will not have any trace of execution. There is no logs, or it won't generate any output, or it won't create any files or reports. It is just for execution purpose. That's all. All those applications we called as a stateless application. But apart from that, there is something called stateful application. So these applications that runs in the container and leave a trace of execution in the form of, what you can say, reports or logs or any output files, anything. It will be having some trace of execution. That is what we call a stateful application. So when container was introduced, okay, in earlier days, the container was meant for stateless application only. You just run the container, you just deploy the container and it has some application, that's all. We never use any data. We never pass any input to the container or output from the container. But over the period of time, when microservice-based architecture came into picture, the container also need to process some data. It also needs to manage some data. Got it? So let's say, for example, consider I have a front-end container. This is container 1. And this is my application logic. Assume that this is container 2. And here we have another thing called the database layer. Container 3. So when I run all these containers as a service, okay, as a single service, I want to run all these containers. So when I deploy this, assume that this is my front-end container, which is having a Tomcat web application server. This container will be exposed to internet using the host IP address. We can able to access the container as like this, right? Now, end user will enter some input value. Like if it is a sign-in application means the service, if it is of a sign-in, means the end user will enter the username and password, and that username and password will be stored inside the container, and that has to be sent to the container 2, right? Hope you're following this approach. Now the application logic will process the input data. If the data is valid, it will just send the data to the database for querying. Once the data is available, again, database will retrieve some, throw some response to the application, and the application will again send the data back to the front end for the end user. So this is how the request and response will be processed internally. So in order to store the data, whatever data user is entering to the system or application, in order to store the data, the container should have some volume. Am I right? And this volume, it is not just to store the data, it is also used to pass the input to the next volume. So it means whenever the container is expecting some input, or whenever the container is generating some output, that will be managed with the help of the container volumes. Are you clear with these points, guys? Hello, hello, hello. Am I audible to all?
Can you please come again with volumes?
What happened?
I got this point, like how it works in 3-tier, like, we need some volumes for the data, but I don't get it specifically for what purpose we use it.
Okay. So ultimately the volumes are used to manage some input and output data of the container. Got it? Let's say this is my container. This container needs some input, right?
Yes.
So that input is sent from container 1. So in order to hold the input, it needs some volume. Similarly, this container is going to generate some output. To store that output, it needs some volume. So that's what the trace of execution means. So that trace will be in the form of the output files or logs or reports, or it can be any property files or any parameters.
No, my concern was, I understood this, but my concern was for each container, we will be having different volumes, right?
Yes.
Okay.
For
So
each
not
container
a
will be having the different volumes, or
yeah.
you can able to have some shared volumes. Everything is
Okay.
possible. Is that clear? So understood the concept of, a reason behind the container volumes, right? What is the need for container volumes?
Yes.
Okay. So in Docker, we have a command like Docker volume command followed by the list. So if we simply say Docker volume list means it will get you the complete list of volumes that are associated. As of now, we never create any volume. That's why the list is empty. So if you want to create any volume, you can use a command like Docker same volume followed by the create command, create, and they give a volume name. Volume name, it will be like say regular DevOps VOL1. That's it. So I created a volume, and these volumes are considered directories in your machine. Okay. So if I say Docker volume inspect command, you can able to see the properties of the volume. See here, this volume is created And the mount point of this volume is this path. So in my host machine, in the Docker installation directory, I can see the volumes. Sorry. Okay. So in this directory, I can able to see the volume. So it means this directory is considered as a shared directory or shared path for my containers. So whenever I run any container, I can able to use this directory as a shared volume. So now let me show you. Let me run one container. Before that, let's give a command docker run or docker volume list command. So this is the name of the volume which we just created. And what I'm going to do here is I'm going to run a container docker run -it. I won't run in interactive mode, but I'm going to use the volume whatever I created here, -, mount, followed by the volume, that is the source, equal to, this is the volume. And the destination is equal to / the volume name. And I can say like CentOS. CentOS image is already there with me, so I can use the same image. So what I'm going to do here is, before that, let me show you one more example, because then only it'll be easy for you to follow the things. So now all that I want to do here is, if I simply say docker and -it CentOS, it'll run in interactive mode, right? Hope you're aware of this. And if I say ls, I can able to see the list of directories available in the home directory of this root user in this container. Now let me exit from this container and run this command. So the basic difference is we are going to add a mount parameter that is going to identify the source and destination volume. So the source volume is always my host volume, whatever I created here. And the destination volume is the volume that is going to get created when you run the container, inside the container. Okay, enter. So now that I'm inside this container, and if I say ls, I should be able to see SARDVOL1 is added to this one. Earlier, without mounting, it is just having default directories, but now it has added one new directory called SARDVOL1. So now if I go to the directory, I can able to see the file system. Assume that this container is running on application and that application is generating some data. Okay, this is a file that's generated. I just saved this file inside the container now. Like this application which is running in the container can able to generate n number of files or outputs or reports. Everything is possible, and all these things should be saved in this particular container volume, not in any other directory. If you keep it in any directory, means it is a volatile, okay? It just deletes automatically. But this volume is mapped to your host machine, right? So now let me exit from here. And in my host machine, if I get into this directory, and if I say ls, I should be able to see the file in my host machine. Easy. So it means a container which got executed here, it has generated some output, and that output is available in my host machine now. Because the containers are not a persistent in nature, okay? It just deletes, it just go to exit state, or it might get corrupted at any point of time. Consider some critical applications I'm running inside the container. At one point of time, if the container is lost, I just miss the container, what will happen? Nothing to worry. After all, just a container, and everyone knows the container is not having a permanent lifetime. At any point of time, we might lose that container, but we should not lose the data. that is generated by the container. So that is the reason some critical applications, whenever you run, that container will be mapped with the volume. So even if you lose your container, the data will be stored in the host machine without any issue. Not only this, I have this file, right? I'm on my host machine. Now let me create another file. File from host.txt. So I have this file created in this directory. And now if I run a container with the same image and the same volume name, so what will happen? What is expected now?
It won't have that. I mean, it will have that file because it's of sharing of the volume between host
So
and the
this
container.
it will create a new container now. And if I say ls, I can able to see the folder. If I say yes, I can able to see the file. What are the files we have created a host machine? We are passing that file as an input to this container. Easy?
So in this case, if let's say in container we created a file and it is almost shared with the host machine. So now in case the container is stopped or lost, we have that backup, right, of that
Yeah,
file.
it will be there in the host machine. That's what the point here.
Yeah, okay.
So we can able to make any number of changes. Even you can able to create any new file here. You can able to add more content. So in this particular file, initially I was having only one record, and this container has generated one record here, new record. So even if you exit from this container, or if container got deleted also automatically, you have the content with you. What is it? File in the host machine. Easy? Guys, am I making things clear to all?
Yes.
Okay. So I'll stop with this for now. If you have any queries, please let me know. So I'll be sharing all these commands. What are things we have execute? I think it is in my machine, this machine. Okay. So this is something important for you. This one, right? Okay. From here, I'll copy for volumes. This. Okay, guys. So no problem. I'll just share it with you. The commands, what are things needed, it's available here. So main thing is you should understand the purpose of volume and in which level we'll be using it for stateful applications. So without mounting the volume, if you run any container, that is considered stateless application. And then it is depends upon application. It's all pure depends on application logic. They are responsible to maintain the files and the outputs in the corresponding container volume. Easy? Are we good for today's session? Any other question? Guys?
No questions, sir.
Okay, I think you all received the poll, right? Feedback something?
Yes.
Okay, it was shared by your support team. Please ensure that you update that. If you have any questions, you can directly ask me, okay? Instead of putting it there. I don't know for whom you're mentioning there. It's okay. Fine. So that's all. I've just stopped for today. Let's tomorrow we'll see more some more concepts related to Docker. like how to create our own images using Docker. We'll see tomorrow.
So I have one question. This is not regarding to DevOps. Like this Mobexterm, we are using unlicensed version, right? So is it valid to use in day-to-day work in enterprise level?
Yes, MobaXterm and Putty, it is recommended. They allow in real time also. I don't find any problem till now. But
Okay.
if you go with the enterprise edition, right, it will automatically take care of the licensing and all those stuff.
Okay. Okay.
Got it. Otherwise, we have to manually maintain these certificates and license all those stuff. That is the main difference. So what they do usually in real time, you must be having a software center, right?
Yes.
From software central, you can able to download those tools.
Okay. So it
So
is not
your
recommended to use unlicensed version in
no. Like, see, no developers or no associates will be having access to download from internet, right? No one will do that in real time. We are not allowed to download anything from internet directly. So we'll be placing a request for this tool, and your support team, IT support team, will try to procure this tool. If it is a licensed tool, means they will procure the tool from the client building or something.
Okay.
Otherwise, if it is an open source tool, means they'll try to download the tool, and they will scan the tool for image for issues or vulnerabilities.
Okay.
And once they find it error free or there's no vulnerabilities, then they'll just inject some security certificates and all those stuff, because they have to certify that.
Okay.
Once you certify, it will be added to your software central, and from there you can download it.
Okay.
Do not directly download from internet. Okay, it is not recommended approach.
Yeah, that's good. Okay. Okay. Thanks.
Yeah. So I'll be uploading these documents. Okay, the content, everything will be in your source code repository. I think I have your repository with me. So any questions, guys? I think only 4 of you here on call. Others, they left for day, I believe. Where's the repository? This is the one, right? I'll create a separate folder for Docker. What is it? Docker? Or you want me to track everything? Okay, it's available here. So any other questions, guys? Please let me know. I think already I have shared this Tomcat installation in the same document. I believe it is there, right? In the class notes itself, I believe. Okay, let me commit these changes. All right, guys. Thank you. If you don't have any question, then we'll close this call. We'll connect tomorrow, 10 a.m. IST. Right?
Thank you, Sai. Thanks,
Yeah.
everyone.
Bye for now. Thank you.
Yeah, sure. Thank you. Thank you all for your time. Bye. All right, guys, I'm closing the call. Okay, thank you.
Thank you.
Yeah, thank you. Bye.